घर के बाहर ही लगा दे रहे हैं।
अभी तो कम हो गया, पहले गोवा में दरवाजे पे पोस्टर लगा जाते थे, इस घर में मरीज रहता है।
अब पोस्टर कम पड़ गए ना, मरीज इतने ज्यादा हो गए कि पोस्टर कम पड़ गए।
अब लोग आदी हो गए, पीपल आर टेकिंग इट एज अ पार्ट ऑफ लाइफ। Shall we start?
Yes, it is 3 o'clock.
So welcome all, good afternoon, and I welcome our keynote speaker, Dr. Rajiv Nigam. A brief introduction I would like to give for the youngsters. Dr. Nigam is a former chief scientist and former deputy director of National Institute of Oceanography, Goa. Dr. Nigam's unique way of carrying out his research has been that he has applied his knowledge of microfossils in various fields, right from taxonomy to paleoclimate, paleoceanography, paleomonsoon, marine pollution, and of late I have been seeing his keen interest in the archaeology, where also he is using the microfossil. He has been a great communicator and is known widely for connecting his various aspects of research. Say, for example, his work on sea level changes, and now whatever work he is doing in archaeology, he has very well connected that. One of his greatest contribution has been to set up a state-of-the-art foraminiferal culture laboratory at the National Institute of Oceanography. We had the opportunity to visit that lab several times, and now that is being looked after by his protege, Dr. Rajiv Saraswat, who was our former colleague also. Dr. Nigam has a wide experience of working abroad also. He was with John Thede in Oslo University, Norway. He was in Woodsole Oceanographic Institution, USA. Also, he was a senior visiting professor at the Chinese Academy of Science, Chinese Institute of Oceanology, China. He has also trained the micropaleontologists of the Iran Geological Survey in Iran. So he has, besides this, a wide experience of attending several international national conferences, and he has given, I don't know the number, but maybe maximum number of invited talks amongst all the micropaleontologists. He has to his credit several awards and honors, which I am sure you would not like that I mention. But one of the best award which I am aware of, which he has won, that he has won the heart of thousands of researchers who came in his contact, including me and my students. That is the best award I have seen Dr. Nigam being conferred. He has left a rich legacy as a great academician, both in infrastructure at NIO and in human resource. Two of his very bright students, you can see Dr. Khare, Dr. Rajni Panchang here, attending this conference. So, a wonderful orator, original thinker, great science communicator. I welcome you, Dr. Nigam, for your keynote address. Please bless us with your wonderful oration.
Thank you, Professor Devesh, for your kind words. Devesh was very generous in introducing me because he happened to be my old good friend. I'm very happy to see Ashutosh here, Dr. Khare, Rajni. I see Dr. Vaidya, uh, Dr. Vadwan, Dr. Pan. Many of the known senior faces are here. It's always pleasure to talk to the students. Lifelong I work with the students and that's my passion. And whatever I'm going to present today, for every work, there is a partner who is happen to be the student. With this, I would like to share the screen, PowerPoint, and Ashutosh. If you see that the screen is properly ready, then you can say yes so that I can start speaking. Okay?
Okay, sir. Okay, sir.
आपकी स्क्रीन आ गई है, स्लाइड शो मोड में डाल दो। यस, इट इज विजिबल।
Yes.
Okay.
इसको
Slides
स्लाइड
आ गई।
शो मोड में कर दी।
Now it is in slideshow mode.
अभी
Sir,
हुआ नहीं।
Sir, I
full screen.
It's a full screen. I can see on my computer.
सर रुकिए, शायद थोड़ा सा रेंज डिले लैग होगा।
Okay.
So you may not have shared your full screen, only partial.
Sir, when you start sharing from the Google Meet, select the option and select entire screen. Then only it will be in full screen. So you can cancel it and reshare it again in Google
तो
Meet.
बंद करिए इसको। सर वापस स्क्रीन शेयरिंग पे जाइए।
Okay.
जब आप स्क्रीन शेयरिंग पे जाओगे, वहां पे आता है शेयर एंटायर स्क्रीन।
Okay.
So you please go to the Google Meet window where this Google Meet window is open in Google Chrome.
Let's see. Can you see the screen now?
Yes, sir, your screen is visible. Please put it in presentation mode.
सब प्रेजेंटेशन मोड में डालिए नीचे।
There is some problem I am encountering.
राहुल,
Yes, sir.
जस्ट स्टेप बाय स्टेप उनको बताओ ना।
Sir, you please go to Google Meet window in Chrome.
No,
So it's
Google
not-
Meet is already there. Only the sharing is
So you please cancel this presentation first.
सर बंद करिए स्क्रीन।
okay.
Now you sir go to the Google Meet window where there is an option present now. Fifth option from the left. You got it present now. So this is just next to the raise hand option, present now.
Yeah, there only I have one.
Yes, sir. In that, as you click on it, there is the first option, your entire screen. Select that. Yes, sir. So now you can go to the presentation, PowerPoint
Yes,
presentation.
please. So many things I am seeing here. Oh,
So you can directly
Oh,
go to the
बस
presentation.
अपना पावर पॉइंट क्लिक कर दीजिए, आ जाएगा.
At the
नीचे जो
bottom.
पावर पॉइंट का आ रहा है ना आइकॉन, बस उसको क्लिक कर दीजिए.
हाँ सर, इसके नीचे आ रहा है सर, बिल्कुल नीचे. So on the left, yes sir, थोड़ा सा लेफ्ट में नीचे आ रहा है. सर वो that is because of mirroring, उसमें नहीं जाना है, नीचे आ रहा है, बिल्कुल बिल्कुल बॉटम में आ रहा है. हाँ सर, ये this one.
बस बस.
Now you go to the first slide in presentation mode.
double click first slide.
And अभी प्रेजेंटेशन मोड में
Now it is, yes it is
Bas,
open.
bas,
आ गया.
okay.
नाउ यू कैन स्टार्ट.
And so you click on
Okay.
this hide button. So you click on the hide, which is written, yes sir. Now it is
Yes.
open.
okay. This is a problem. Huh? Actually, this is very not very pleasant to talk on a screen. You can't see the people's eye and the faces. Okay, so let us start. The role of foraminifera in detection and mitigation of marine pollution. Friends, these days, we all talk about development. And if you remember that initially the society and earning of the society was mostly based on the agriculture. But after the industrial development, there was more emphasis on the industries, and then industries and developments almost became synonym because more jobs are being created because of the industries rather than the agriculture sector day by day. But the industrial development have its own problem. You can have the development, but at the same time you have to pay for it in form of the price, you have in form of the environment. So the question always comes, whether we should stop development is not possible. And then whether we should ignore the harmful effect on the environment, that also we cannot ignore. And therefore a new terms came into existence, that is the sustainable development. So we'll talk about what is sustainable development and where as a paleontologist we can also can play a role. See, when it comes to the environmental issues, and particularly the marine environment, you can see the marine environment, normally people identify it with the fishing resources. There were about more than 3,400 kilometer coastline of wave, and fishing villages are about 1,761. A lot of people depend upon the fishing industries, not only the job, but also the food requirement also is being met by the sea. But when the development comes, one of the preferred areas for establishing the industries is the coastal areas. First thing is that it's an easy transportation of the goods through the sea route, availability of land, and what people find very convenient to establish the factories along the coast area, the discharge of the affluent in the sea, the easiest way. Therefore, there is a concentration of industries all along the coast. Most of the metros also came on the coastal areas. But if we see that, if we allow unquestionable growth of the industries along the coast, the positive gain has been negatively compensated by the loss into the fisheries due to pollution. So the environmental issues related to the marine environment is put into the pollution. And when we go further, we say whether it is how to monitor or why to monitor pollution, how to monitor, and whether it is possible to prevent. And there is a quest to monitor the health of the coastal marine water because maximum fisheries which is badly affected by the pollution, comes from the coastal areas. But before we go further, let us define what is the pollution. As per the US Presidential Advisory Committee, environmental pollution is the unfortunate alteration of our surrounding wholly or largely as byproduct of man's action. And the word marine pollution is used where normal marine environment is changed due to man's action. Now, the question comes, how to get the idea whether anything is polluting or not? What are the tools? Because, see, our experience in NIO started with the Zuari Agro Limited in Goa. And when this factory was somewhere around 1975-76, there was agitation by the local fishermen. They say they are getting less fishes because factory is polluting. But factory says, no, we have checked our affluent and we are not. There was a big agitation, and then that was the first project which came to NIO. So someone has to decide that any factory's effort is polluting the environment, it is not the pollutant. So the question comes, what are the available tools? One is the chemical tools, other one is the biological tools. But here today, I'm sharing my experiences with you with an additional tool, or which is the new tool, and which I feel is the better and best tool to go for detecting the marine pollution. Let us say normally how we do the detection of pollution is by chemical methods. You go collect the samples and see, for example, if mercury is there or not. But there the problem comes. If the person who is discharging effluent is clever enough, he can, before you go for sampling, he will stop the effluent point for say 1 month. And when you go and collect the sample, you will give a report that there is no pollution. He will ask you for sampling during the monsoon time when it is already diluted. To counter it, you can go every month. Every flight. The project becomes very expensive. Oceanography is a very expensive science. So we need a tool which can give you an idea whether factory is polluting or not, one-time sampling. Other method which biologists now are using, putting the fish into a tank and giving them as a media what is the effluent of the factory. But when you are using fish to check this, and if fish get affected, it means pollution has gone beyond control, irreparable. So what we need a tool which can detect the pollution at the very beginning, and that we say is a microfossils called foraminifera. See, other fossils like ostracoda and other things also can be used, but today I am just presenting you how foraminifera can be used. So those who are not from foraminifera, I would like to tell few words. What is foraminifera? See, they are single cell organisms having a outer coverage called test or shell. There are two types of foraminifera. One is the planktonic foraminifera, which live into the water column and normally away from the sea. But benthic foraminifera, which they live at the nearshore bottom environment, and after their death, both get deposited at the bottom of the sea and serve as a pages of the history of the environment changes in that area. Now, foraminifera are extremely sensitive to the environmental changes. A slight change in any of the environmental parameter brings a lot of change into the morphology and assemblage of the foraminifera. They are exclusively marine organisms as far as the fossils are concerned. And this sensitivity we have used for variety of application. Almost every wake of the marine life, we have used the foraminifera. For example, we have used in paleoceanography. Sediment transport today, I will just cover this part, which is an engineering application. This is an age-old application, is petroleum exploration. It's a Almost every textbook we taught at MSc, they use petroleum exploration. Monsoon variation. This is one of the very important field in which foraminifera applied to get about rainfall records of the past, and it's how it is helping to get the idea about the future rainfall. Fisheries, particularly this is becoming very important in view of the global warming problem. We can also talk about paleo tsunamis, the sea level changes, how sea level has fluctuated during last 10 to 15,000 years, which has played a very important role into the coastal areas, particularly in the field of marine archaeology. The Dwarka, Dhalavira, Ram Setu, they all come under where we have applied for marine archaeology. And today, I will be taking up the pollution monitoring as well as the sediment transport, these two. They are interlinked in some way. So let us see how it is possible. What type of samples we need if we want to study the marine pollution? See, we use the property that is sensitivity of the foraminifera towards environmental parameter. That is the main property which we use. We need three types of samples to say that whether it is polluting forams or not. One is the surface sediment sample, like the graph sample, you can collect the surface sediment sample. You can have a short coring. Of course, this is for long coring, but with this help of winches, you can do a coring. And the sample with time gap means it's preparing the baseline data. What we started doing, if any factory is coming, pre-factory survey and post-factory survey can also tell you about the effect of pollution, whether it is the effluent is polluting the environment or not. The simplest way, the surface sediment and the short core, see, if you collect, this is a factory of, which is a source of pollution. You can collect this grid pattern sample, surface sediments, or you can take a short core sample. Ideally, the sample from the same depth should have a same type of one, if there is no additional source or like pollution. If pollution is there near to the effluent discharge point, you get the effect, which will, as you move away from the source, the effect will be diluting or getting almost normalized. So, comparing the total assemblages of foraminifera near to the effluent discharge point and away from it. Another method is, if you don't want to go so many samples, you can take a short core. And you can see the pre-factory deposition with the lead 210 dating. You can see that how much is deposited pre-factory and post-factory. And ideally, they should be same if the factory is not polluting. Otherwise, post-factory sample will tell you. See, the beauty is, whatever factory you close it even for 1 year, the factory has polluted, the post-factory survey can tell you this factory used to pollute you. So no way any clever industrialist who is polluting the coastal environment can get away if you are using the foraminifera as a tool to detect the marine pollution. So what type of results comes? See, the first thing in any live form, whether human being or whether it is fishes or whether it is foraminifera, initially the individuals get affected. A few specimens of foraminifera will start getting affected moment the pollution starts. This may be a type of corrosion you can see, or you can see a morphological abnormalities. If the intensity of pollution is increasing, you can get some species, particularly in case of organic pollution. Some species take it as a food and they multiply more in number. Some is opportunistic species, what we call it. They grow more in number on the cost of the other species, that is called the negative effect. And then the pollution level is becoming very extreme. The entire fauna is affected. They say low or high total foraminiferal now, or the size of the specimens. So now I will tell you the example of each type of this. These are some model areas I will tell you the history of marine pollution studies started from this area. This is near Vasco. It's a Zuari Agro Limited. And Dr. M.G.A.P. Sethi, who happened to be the project leader, and I joined NIO when this project was going on. And this has actually established in our country that foraminifera can be used as a tool for marine pollution. And the first paper which we published there have more than 150 citations. So this was the agro industry, this was the alkaline pollution here, this was the titanium TTP site at Trivandrum, and this is Thana Creek area. Now we have published a series of papers individually in each area and a collective review, and they are available in open literature. If you want to see the review, see the Environmental International, which have about more than 200 citations. First, the individual type of effect. You can see that this is, if it is a normal specimen, it should be like this. Now it has developed the two modes. You can see some specimens who are joining. So when this population are threatened, they try to develop certain strategies by which they can sustain and they can still grow. In the process, this type, the paralysis type of effect. Similar type of effect has been seen in the human being in a Unnao district of UP when the Khesri dal was there as a pollutant. An entire village population were almost got paralyzed. Same happened here. The lot of individual specimens of foraminifera show the effect of paralysis. The other one is the specimens getting entire species population. They are getting distorted. You can see the last specimen becoming shorter, in between few short specimens. So whenever you see, if you get only few specimens, you cannot say that they are indicator of pollution. Because if in any village, if you get one or two paralysis cases, you cannot say that this village is affected by pollution, unless a substantial number of population is affected. So here also, if lot of population is getting affected, you can say this is a species that it has gone from individual level to the species level. I was talking about the opportunistic species. Some species need a particular type of food, and if that comes in form of pollutant, the species like ammonia, it gets reduces. Less. So in a normal sample, in a gram, for example, you get 10 specimens. In polluted environment, you may get 1 or 2. There is some other species like Stenfortia. It multiples. So normally, if you getting 10 specimen in a gram, you may get 50, you may get 100. So if only few species are dominating and that effect is not seen at the same depth in the nearby area, you can say that there's something wrong in this area. We have publication of whatever result, each one is supported by a paper. Now, well, almost entire fauna is here. Not only individual species, but entire fauna is getting affected. Or if an acidic type of pollution is there, you can see a lot of the test, which is made up of calcium, is getting dissolved. And only the keels and other hard parts are remaining. This was done by Kamesha, another scientist from NIO, who has done the initial work on foraminifera as an indicator of marine pollution. But you can say the best example or the worst example is Thana Creek, where we have done survey. We found that no living fauna, because that time 20 factories were throwing their waste directly into the Thana Creek area and no foraminifera population survived. I believe after that there were a lot of government tools came, lot of processing units came, and some population. I remember seeing, I forget the name of that girl, but I remember one paper she started showing some foraminifera fauna, but I was not sure whether she was talking about living foraminifera. But when we were presenting this work and publishing, we were questioned. And I think the questions were also very valid questions. They say you people have gone to an area which is known for pollution. Some factory was there. You collected the sample and whatever you found abnormality you attributed to the effluent from the factory. There may be some natural causes, there may be some other causes. How you can be so sure that it is because of this factor? And I agree, this doubt was a very valid doubt. So we have quite later, in between we were doing some paleoclimate project, and then we came back to this project, foraminifera as a pollution indicator, and we established the culture experiments. This is the only lab in the country, or in case of South Asia, which is culturing foraminifera. The effect under the various parameters we observe. The beauty of culture experiment, you can keep many factors constant, and you can vary 1 or 2 parameter only at a time. So we have established the culture experiment, and for that we have taken the offshoots of a single specimen. See, this is a mother specimen, and you can see now in the lab it is reproducing. These small babies are coming out. Now we picked up the babies and we put it into the culture experiment. Now in culture experiment, you can maintain all other parameters constant, and you can only add certain things. Now in this case, we have added mercury. Okay, now you can see here, this is a normal specimen in the culture experiment from the same mother. You can see how beautifully normally this specimen has grown. But here, when we have added the mercury, you can see the abnormality in the culture specimen. And not only that, you can see here, as the mercury concentration increasing, the growth is also affected. So the dwarfing, the fauna also becoming dark. So this has given a very confirmatory test that yes, because of pollution, foraminifera do show its effect. And now what we have published or talking before now have a credibility through culture experiment. We have published a series of publication into Journal of Marine Biological Affairs, UK, Revista Italiana, Marine Pollution Bulletin, and so on. There are so many. Another method, and particularly this culture experiment, I want to take the 4 names actually. Namdev Kohli was the first one who helped me to establish this culture program. Then Sujata Kurtarkar and Rishi VN, they have done this job of culturing foraminifera in the lab, out of which Rishi also bagged the Young Scientist Award for using foraminifera as marine pollution through culture experiment. Now I am telling you how we can check the mining pollution. Goa is well known for that. Now we have open cast mining, and during monsoon, whatever waste is there is washed into the sea through estuaries. Now, luckily, we have a 1974 samples of Mandovi estuary by Dr. Kamesha Rao, and then again we have sampled this study. And what we found, see, over the years, the suspended load has increased, which is indirectly indicating the increase into the mining activities, and total foraminifera population came down. You can see from 70 to 90, we have done this here. And the data showed the specimen started reducing from 200 gram to 138, only 41 specimen. And with this help, we have concluded that a drastic fall in total foraminifera number indicate a mining pollution. Rajni and Priyanka Banerjee has done this work in the neighboring estuary of Zuari. And they found that instead, unlike Mandovi, the number has increased. Today, I have not put up those slides. And they have related it with the change in the mining pattern. Initially, mining was for manganese and Zuari was affected. But of late, mining shifted to iron ore, which is mostly into the northern area, and Mandovi draw its water from it. So here you can say foraminifera can also be used to detect the mining pollution. But once the pollution is detected, what next? Can we stop the factory? No. We have to keep the factory because they are the best at the job providers. Then what we do, at the same time, we cannot allow the coastal area to get diluted. So the best way is this effluent through a pipeline, and finally a diffuser should be put in the deeper side where the currents take this pollutant into the deep sea where it gets diluted and its effect is minimized. Now, there are certain rules about the laying the pipeline. See, pipeline should be buried into the sediment. Otherwise, during the dredging, it can get damaged. Now, this pipeline should be into the soft sediment, only then it gets buried. Otherwise, you have to do the trenching. Okay, and there should not be any sediment transport. But what happened? See, we have done a pipeline here, and you can see pipeline was covered. But after that few years, when we have gone, we see the pipelines are exposed. This was done because nobody bothered to do the sediment transport history in this area. There are many methods for sediment transport studies for laying a pipeline like sediment tracer and mineral tracer. We can supplement this method by the foraminifera as well. And here also, like pollution studies, one-time sampling. You need not go for repeated samples. See, foraminifera have a soft part called pseudopodia, which is 10 times the size of, sometimes even more than that. Through this pseudopodia, which is multi-purpose, they collect the food somewhere here and they start contracting and the food comes to its mouth. At the same time, it anchors themselves because with the help of pseudopodia, they anchor themselves to the substrate and thus is resist any site of transport. So if in a living form, ideally, if there is no sediment transport, living and dead foraminifera should have a similar pattern. Means if 10% is in the living any species, dead also 10% should be here. But if 10% going this side or this side, it means sediment is moving either in this direction or that. Because after their death, pseudopodia decay and the foraminiferous behave like a sediment grain and subjected to any sort of transport. Now this model we have tested in off Nawapur area. And you can see this is a living and this is dead. Living was only confined to this area and dead is covering this entire area. So it means sediment is moving towards this direction, from this direction to this. The sediment transport direction was actually the resultant of because a lot of fresh water from Narmada Tapri Sutherland channel comes and pushing the sediment to this side. This area we got the sand wave. Okay. And the tidal force pushing the sediment towards this direction and resultant is this direction. So the net sediment transport direction can also be tested or can be deciphered with the help of foraminifera. Therefore, now we can say that foraminifera are useful in detecting the marine pollution. And once we decide that yes, the effluent is polluting the coastal marine environment, we can also help to find out the mitigation and where and how this effluent should be discharged into the sea. Finally, we can say that we can prevent the foraminifera from incorporating the evidence of pollution by stopping pollution. Let us strive to make our sea pollution free. Thank you very much.
Thank you, Dr. Nigam, for finishing your wonderful talk within time. So we had time for taking a couple of questions. So the floor is open to the audience. If anyone wants to ask any question, please directly ask the speaker.
What happened to the students?
The students have a general hesitancy in asking questions in public.
Okay, if they are not asking question, allow me to ask a question. Whether anybody can answer me, whether we can check by this method the pollution in Jamuna River. Whether any student wants to try.
They will not speak. Niloy, close your speaker. Okay. we have to start the session,
Okay.
and I thank Dr. Rajiv Nigam. Talk. I hope audience have felt the power of foraminiferum, that it can be used besides academics, research, paleoclimate, in a number of ways to study the marine pollution. And also he suggested the mitigations based on the geologist or marine geologist's knowledge of the oceans. So thank you, Dr. Nigam, once again for accepting
you.
our invitation and delivering this talk. So we begin the session.
I
The
think
first-
somebody has the rain. Some Raj Kumar has raised the hand and Pankaj Srivastava. That's what they are showing it here. They have any
Yeah,
question?
Yeah, Pankaj, please ask. Yeah.
I think it was just thank you, sir, so much for giving this wonderful talk. I was just wondering, one of the solutions that you have told, that putting up a pipe down deeper and making the pollutants much more diluted, so that the coastal areas can be saved over there. But I think there could be one more possibility, that why not check the pollution at the factory level itself? Why the outlet of the factory should not be given a kind of treatment? They should treat the water or whatever the sewage or whatever the polluted they are doing, that should be treated one.
Exactly. And now it is mandatory actually to have a treatment of the pollution within the source area. But every time it is, there are two things. Entire effluent cannot be treated in some of the cases. Okay. So in that case, putting up a pipeline and whatever is going out, go to few kilometers. It's not very long pipeline. It depends upon the physical oceanography, how the current taking the effluent towards the deeper side. Okay, and this being implemented for the factories
Please
all
ask.
along
I
the west
didn't
coast.
see your hand. Please ask. Yeah, Partha wants to ask Professor Partha Chakrabarti. Professor Partha?
Partha from IT Kharagpur. Okay.
No. There are several types of Partha. We have the Partha
Okay.
Chakrabarti.
Okay.
We call him only Partha.
Most welcome. What is the question?
ये कहाँ से ये आवाज आ रही है disturbance?
Some people have put their mic on. I think please, others, please put your mic off. All others, please.
See, those who are asking questions only can put on the mic. Remaining can put off. Yes, Partho?
Professor, you're not audible.
Rahul, can you manage it?
Okay.
Sir, this is because of clash of the voice. This is I mean, everyone has to mute their mic.
I think you can also do it at your end, whoever is manning this. Who is the administrator today can put off the mics. And then whoever is raising the hand, only their mic you can unmute.
So I have muted all the participants. Now those who want to ask, they can ask.
Raj Kumar
Partha,
Singh,
please ask your question.
now his mic is muted.
So I think there is some problem with Partha sir's mic. Sir, you please rejoin.
Okay. Okay, those who have question, can send me the question. Okay.
Yeah. Am I audible now, sir?
Yes.
Yes, sir, you are audible.
Yeah. Sir, yesterday actually one student, he was actually presenting one presentation that he was showing that because there is a brackish water in Chilka Lake, there is a dwarf development and the full-scale development is not there. Today you are talking about the pollution also. That also is causing lot of damage. Now how we will be then identifying whether the dwarfness in species, that is because of the salinity of the water or the pollution of the water?
See, pollution is a rather localized phenomena. Okay. And the specimens which is I am showing you as an effect of pollution, they are more near the source.
Okay.
If you go few kilometers away, you don't find those type of abnormal specimens.
Okay.
Okay, so that is the way you can say it is because of the industrial pollution. Chilka Lake brackish water is a natural phenomenon. It's not a pollution.
Yeah, exactly.
Okay.
Exactly.
Okay. So whatever fauna you are getting, it will be mostly agglutinated type of fauna, which is more prominent in brackish water. But if any factory directly or indirectly throwing their effluent into the Chilka Lake, then you can do a local sampling nearby and compare it with the little away from it. You can say whether factory is polluting or not.
Sir, I have very little idea about this thing. I am a sedimentologist, but Picambian sedimentologist, very little idea. So, yeah, because I heard that thing, that's why I am asking the question to clarify my doubt.
Okay, let us thank Dr. Nigam for his wonderful talk, and we begin with the first presentation is by Dr. Pooja Yadav.
Okay.
Dr. Pooja Yadav, are you there?
So please don't call her doctor. She is still doing her work. She is
Maybe I have some information. Pooja Yadav, are
Sir,
you?
yes, sir, I'm here.
Yeah, Pooja Yadav is going to present on the paleopedology of the lower Shivalik paleosols, and it appears in the abstract volume on page number 42. So Pooja, please start your presentation. You have 10 minutes.
Yes, sir.
Dr. Nigam, please stay with us.
Sir, is it visible?
Nothing is visible.
Not now. Yes, no.
Yeah, it is coming now. Okay.
User, click on this hide button.
Okay, thank you.
Now it is there.
Good afternoon, everyone. Today, I'm going to present on paleopedology of the lower Shivalik paleosols, implications of for weathering and climatic change during 12 million years to 10 million years. So this study is totally related to paleosol. So why paleosol is so important? It is because of their formation at Earth's surface directly in contact with atmospheric and climatic condition. So paleosol contain a variety of components such as soil carbonate, organic matter, and clay minerals, which are sensitive tool for reconstructing past climate and vegetation history. As we know, the Himalaya erosion is considered as one of the best examples of continental-continental collision, which took place between Indian and Eurasian plate. In this Himalaya mountain range, in the base, we have Himalaya Foreland Basin, which is bounded by main boundary thrust in the north, main frontal thrust in the south. This Himalaya Foreland Basin is divided into several sub-basins based on some lineaments. And in this sub-basin, Kangra sub-basin is my study area. This is the geological map of the Kangra sub-basin. And here is my study area. So here the sampling was done along a small nala. Here the lower Shivalik, and this is the middle Shivalik. This is the simplified lithologue of Ranital Kangra section, which is 2.2 kilometer thick. Here the lower Shivalik, which is 280 meter thick, and the time is 12 to 10.5 million years. So it becomes very critical to study about the lower Shivalik in terms of tectonic as well as the climate, as some researchers like Kumar et al. 2003 have suggested that the reactivation and the reactivation of MCT and the activation of MBT took place during this period. And here what we observed that an alteration of sandstone and mudstone bodies were there, where mudstone was more than 50%, and the paleosol was brownish yellow in color, and the sandstone geometry was both ribbon and sheet geometry type. So as I mentioned, it is very important to know the paleo-environmental condition and which during this time. So here the paleopathological features help to find these. So for that, I worked on characterization of paleosol horizon and pedogenic variability of the paleosol, micromorphological details, and clay mineralogy of the paleosol during this time. Now, starting from the macromorphological study, in the lower Shivalik, I took the paleosol from the 17 profiles. So in the lower of the lower Shivalik, like in LK4 profile, we observed that there were some motels and bioturbation, and few roots were there. So the paleosol was weakly developed and the horizon were BW type. And in when we moved in upward, then like in LK17 profile, we found silicon sides features and also calcium carbonate nodules up to 1 centimeter. So the horizon was BSS, BK type, and BW types. So there were some little development when we moved upward. And on the basis of micromorphological study, we found many key morphological features like structures, fidelity, texture, B fabric, clay coating, rhizocreation, extensive pedogenic calcium carbonate, motels, and bioturbation features. As we can see in the middle of lower Shivalik, here, there's some faunal activity were observed in the paleosol, and the vest-shaped structures were also there, which shows that the pedogenesis took place. And here the mineral alteration and the clay intercalation also shows the weathering took place. And similarly in LK14 we observed in the again bioturbation, some motels and voids and cross B fabric. So it shows that weathering was higher in the middle of the lower Shivalik than upward. Now, when we do study, climatological study, then I observed the clear variation from lower to upward in LK1 to 14 profile. In LK1 profile, we can see here the peak of smectite 17 in the calcium chloride plus ethylene glycol treated samples. The smectite peak was very broad, and if we see the kaolinite peak was very less intense. And when we observed in LK4 profile, then there were the smectite peak was disappeared and the kaolinite peak intensified. And in LK9 and 14 also, there the very weak intensification of the smectite mineral, and the kaolinite trend was increasing, intensification was increasing. And similarly trend in LK14, that there were a little amount of smectite increase. So we can understand this variation by semi-quantitative estimation of clay minerals, that in LK1 profile, the smectite percentage was up to 45%, and the kaolinite percentage was only 5 to 10%. And in LK4, when we move upward in LK49 profile, the kaolinite percentage was increasing and the smectite was very less in amount. In LK14, again, the smectite increased a little and the kaolinite percentage decreased. So here we can see the presence of smectite in different profiles shows presence of some aridity, and the presence of dominance of kaolinite in the profile shows humid to subhumid climate. So we can interpret here that the in the lower Shivalik, the climate was the arid, becoming the arid to humid to subhumid. So we can conclude here that the paleosol of lower Shivalik group shows dominance of weak to moderate developed pedogenic features. The paleosol shows BW, BT, BK, BC, and BSS horizon with key pedogenic feature as roots, motels, and carbonate nodules and pedogenic structures. Pedogenic carbonate nodule occurring as dense impure micritic nodule shows that formation of pedogenic carbonate due to seasonal condition resulting in fluctuating monsoonal strength. And here the presence of smectite in the paleosol profile at different interval from lower to middle Shivalik subgroup shows some aridity, and absence of smectite and presence of dominance of kaolinite in the different paleosol profile shows humid to subhumid climate. And this early study also support the Jacobs et al. 2001, which says that a short-term transition to a warmer climatic phase during the long-term cooling interval as evidenced by isotopic studies. Thank you.
Thank you, Pooja,
Yes, sir.
for being in time. The talk is open for discussion.
Pooja, you have
Yes.
told about change in paleo environment, arid, humid, or subhumid. If you want a quantitative data, what type of analysis I should do? You are talking about qualitative.
Yes, sir.
If I want to have a quantitative result, what type of further studies I should go?
Sir, we have some other proxies also, like geochemical chemical studies, and and there are studies of isotopic studies, which I think will help in that.
Which isotope we should go in your area?
Sir, for the identification of temperature, we can use the in soil, even in the soil carbonate, we use delta O18, and for the carbonate, the vegetation changes. We use also carbon 13, delta carbon 13 isotope.
Anybody is doing it in Shivalik sediments other than you? This type of
Yes, sir. Yes, sir. It is used by extensively by the Sanyal, sir. Sanyal et al. 2004 in entire Indian region, and in the Pakistan, it is done by Quad et al., which was started from 1989.
Okay, thank you.
Okay, Barnita Banerjee wants to ask some questions.
Yes,
Yes,
ma'am.
Pooja. Since the scale of time on which your work is like middle Miocene, 12 million years to 10 million
Yes,
years,
ma'am.
so that is a very renowned time for the strengthening of the monsoon and intensification. Do you have anything to say on that? Any comment on, because you worked on weathering and all these things, but you haven't not commented anything on the
Yes.
monsoonal conditions.
Yes, ma'am. Ma'am, actually, the in our Indian region, monsoon intensified in different time. So there are the peak, which shows that it monsoon intensified also in around 12 millions, and what I showed. So as I also talked, the activation of MCT and reactivation of MCT and activation of MBT occurred during this time. So the study of Kumar et al. 2003 also says that due to activation, the tectonic activities, the relief increased due to high relief, and it also attract the moist wind and the monsoon. So this is one way we can see the monsoon intensified due to the tectonic.
Sir, if you allow, I'll
Yeah,
just add.
please
Yeah.
go ahead, Pankaj.
So at this moment, we cannot be committal on saying anything in terms of very, very strongly about the kind of climatic changes that she is saying. But we definitely require very high resolution data that we are trying to procure from the field, from the thin section, as well as from the geochemistry. Once everything is there, then only we can construct all the curves and we can correlate it. At this moment only, it's our primary, you can say, interpretation that the presence of smectite and the decrease of the kaolinite or increase of the kaolinite is giving some signals. But at this moment, I will not commit say that these are the important signals at this moment.
Thank you, sir.
Well, Pankaj, as you have joined, I have just one last query, because I see a lot of information in the abstract which I read. One of it is that the 8 million years, we are finding a sort of very humid climate, and also at 8 million years, if you look at the papers by Kroon et al. Or Bertrell et al., from the Arabian Sea, they have said that the onset of Indian monsoon or intensification of Indian monsoon occurred around 8 million years. And
Yes.
this data is corroborating with the data from the marine record. And second thing is your smectite, illite ratio and all the clay mineral studies. I hope that in future she will correlate with the work of Krishna Swami group of PRL from the Bay of Bengal course, where they have also predicted or they have identified the intervals of intense weathering in the Himalaya, because ultimately the product has been deposited in the Bay of Bengal. Even the paper by Kudras et al., Kuzobek et al., all these papers deal with the Bay of Bengal.
Yeah, definitely. Once we have a complete study of the lower as well as the middle Shivalik and the all the data, then we can say. I think possibly one more topic will one more talk will be there. There, I think possibly we may have some more information.
Okay, thank you, Pooja. Thank you
Thank you,
for
sir.
finishing on time. So next we have Jeetu Shazi,
Yeah,
Upasna Banerjee. Jeetu Shazi,
yeah. Can you
are
hear
you
me, sir?
ready?
Hello.
Yes, are you ready?
Yeah, I'm ready, sir.
So Jeetu Shazi will present his work on Holocene monsoon and sea level variability in coastal lowland sediments of Kerala. And the abstract appears on page number 41. Jeetu, you can start your presentation.
Can you see it, sir? Can you see my screen?
Yes.
Can you see it, sir?
Yes, it is. Please go ahead.
Okay. Yeah, my name is. Good evening, everyone. My name is Jitu
Speak
Shaji.
loudly.
Yeah, my name is Jitu Shaji. I'm a research scholar at National Center for Earth Science Studies. My topic of presentation is Holocene monsoon and sea level variability in the coastal lowland sediments of Kerala, Southwest India. As we all know, the Holocene epoch is the epoch we are living in, and it has witnessed some major climatic perturbations over its time period. And this is one of the reasons why the Holocene epoch is the only geological epoch in Earth's history whose boundaries are defined based on climatostratigraphy. And one of the major climatic phenomena that our country experiences is Indian summer monsoon. Indian summer monsoon contributes more than 70% of the rainfall over the Indian subcontinent, and thereby it greatly influences the socio-economic status of the country. And it actually has two branches: the Arabian Sea branch and the Bay of Bengal branch. And the Arabian Sea branch collides with the Western Ghats highlands, causing heavy rainfall. The southwest coast of India acts as a gateway for the ISM, and it provides an excellent opportunity to study the climatic variations along with the sea level changes that the area has experienced. This is my study area. We have retrieved a sediment core from Kuttur region, Pathanamthitta district, which is located in the southwest coast of Kerala. Okay, the top cover is mostly quaternary sediments, and also the terrains you can see there are Chanakya condylite terrains and some basic rocks can be seen. And a nearby laterite terrain can also be seen here. And the area is drained by two major rivers, Manimala River and Pamba River. And the present day coastal configuration is a result of the past land sea interactions and the climate perturbations. These are some images of the sediment core collection we have done in the study area. We have retrieved almost a sediment core of around 32-meter length using rotary drilling method. And you can see the cross-section images of the sediment core. And we have subsampled the sediment core at a 1 centimeter interval, and we have done several multiproxy approaches, like we have done geochemical analysis, palynological, sedimentological analysis, and also we have obtained almost 10 AMS radiocarbon dates for the sediment core. And this is a lithologue of the sediment core as well as sedimentological analysis details. And based on the sedimentological analysis, we have found out that majorly the sediment core consists of silty clay as well as clay type of sediments. And the Petrups diagram also indicates a calm to slightly turbulent energy conditions. And as you can see from the lithologue itself, the entire sediment core is mostly of clay type, clay as well as silty clay type. And even though only the top 2.64 meter is actually having some coarser fractions like sand as well as silt content. And we have also done a palynological analysis for the same, and certain pollens can be indicative of certain climatic characteristic climatic conditions. For example, the presence of Culenia exarlata can be a good higher rainfall indicator, and the presence of certain terophytic spores like Ceratopteris thalictroids can be indicative of a swampy freshwater flipping kind of environment. And diatoms like Navicula species can also be indicative of freshwater conditions. And this is the palynology of the Kutu sediment core. As you can see, from around 9,500 kilo BB to 7,500, there has been a lot of evidences of marine incursion, like the presence of foraminiferal linings and certain marine diatoms indicates there was the marine incursion has happened in the study area. At the same time itself, evidences of heavy rainfall and warm humid conditions was also indicated by the presence of certain palynomorphs like Culenia exarlata, Tedobatic spores, and Navicula species and cyanobacteria. This time period actually, which actually the sediment core usually almost covers the entire Holocene epoch, and this early Holocene time period actually coincides with the Holocene climate optimum. At that same time, there was warm and humid climatic conditions. This is observed in the sediment core, and towards the top portion of the core, there's a lack of marine evidences, and there are, but even though there are a lot of indications of warm, humid rainfall conditions like tertophytic spores and the presence of certain fungal spores also corroborated. Coming to the detrital proxies, from around 9,600 to 7,000 kilo BP, there was an increased detrital contribution, suggesting an ISM strengthening. There was an increase in TO to MGO values, as well as uh, and the bottom portion of the core was characterized mostly by fine clay, as I said earlier. This is also corroborated by low SaO2 as well as silicon content, and there was essentially as ISM strengthening during this time period. And from around 3,500 to 2,500 kilo, overall there was a declining trend in the ISM has been observed, even though there was a intermittent monsoon spell has been observed in the study area from around 3.4 to 3.2 kilo BP. And at around 1.8 kilo BB, we can see there was an increase in detrital influx, which corroborates with the Roman warm period that happened from around 2.5 to 1.8 kilo. As you can see towards the top portion of the core, we can see a lot of high SaO2 content, TO2 zirconium values, and coarser fractions are obtained here, seen here. This is mostly due to the influx or increased detrital flux by the adjoining rivers like Manimala and Pamba River. And coming to the paleoweathering proxies, we can see during from around 9.7 kilo BP to 7.56 kilo BP, there has been a marginal increase in MgO by L2O3 values, as well as the chemical weathering indices also show a marginal spiked values, but and suggesting that the weathering was active at this time period. And towards the middle of the core, from around 3.4 to 2.5 kilo year, there was gradual weakening of weathering indicated by low MgO by L2O3 content. But even then, the chemical weathering indices actually showing a marginal spike. This could be due to the influx of sediments from the nearby laterite terrain by the rivers. Moving towards the top of the core at around 1.8 kilo a year, there was an increased chemical weathering activity, which corroborates with the Roman warm period time period. Overall, the Kutu sediment course has undergone a moderate to intense weathering conditions and shows textural maturity. And we have used the ACNK as well as ACNF FM diagram in order to understand the weathering intensity and mineralogical composition of the area. And as you can see in the ACNK diagram, the Kutu samples actually shows a gradual decline in K2, Na2, and CEO compared to the upper continental crust values, and follows an ideal weathering trend, and shows an affinity. Majority of the samples shows an affinity to the AL23 apex boundary, and it indicates that there has been an there has been an intense weathering conditions, and when extrapolated backwards, we can see it's actually showing an intermediate sediment source, and most of the sediment samples are actually showing an aluminous character here. And the ACNK-FM diagram shows that in the majority of the samples actually lies within the feldspar spectate chloride triangle, and the with the source rock composition ranging from basalt and granite array, and the remaining samples actually are falling towards the L203 side, showing a felsic source composition. And when CA is plotted with against ICV, it is also showing that majority of the samples are actually has undergone intense weathering and are texturally mature. This paper is a study done by Dr. D. Patmalan in 2014 regarding the evolution of Vembaran Lagoon in tandem with sea level and climate variability during the late Quaternary period, using several sediment cores he has collected from the study area. The present study actually shows the evidences of marine incursion and a calm depositional condition during the early Holocene epoch, suggesting a lagoon, more or less a lagoonal setting, also considering the proximity of the borehole location to the Vembaran Lagoon. So it is highly likely that the study area was once a part of the once larger Vembaran Lagoon. The subsequent regression and heavy input of sediments by the adjoining rivers, like in my case, the Manimal and Pampa River, could have resulted in the present configuration of Vembaran Lagoon.
Can you conclude, Jitu?
Yeah, I'm concluding, sir. Okay, from the inferences, we can say that the sediments have been deposited under calm to slightly turbulent environment. There has been high deterrent influx with marine incursions from about 9.5 to 7.5 calibre BP, suggesting high humid conditions as well as heavy rainfall. Weak monsoon was observed from 3.5 to 2.2, with an intermittent monsoon spell from 3.4 to 2.2 kilo BP. And weathering properties actually suggested intense weathering in the study, and the sediments has a mix of sources. The presence of marine influence in the study area, which is located south of the Vembaran Lagoon, demonstrated a possible southern extension of the lagoon during Holocene, which gradually attained its present configuration after 3,400 calibrate year BP. Thank you.
The talk is open for discussion.
I was just wondering, when you say that marine incursion around 9.5 to 7.5, all other sea level studies are indicating that present sea level crossed the line and gone above around 7,000 years. You are bringing it to 9.5 and everybody else showing that sea level was quite lower. How you can get that influence on the land incursion?
Sir, it was actually based on the palynological evidence that I said, that from almost that bottom portion of the core that we have dated, and the dates were from around 9,500 to 7,500. It has actually shown a lot of marine evidences like this presence of some foraminifer linings and Bithulfia species. So that on the basis of that, actually, we said that there was a possible marine incursion at that time.
See, marine incursion, if you say, it can be in form of say tsunami deposit as well.
Actually, sir, marine transgression is the word I think I should choose.
But is there anybody else told about this marine transgression around 95,000 years else? Anywhere else?
Yeah, sir. Yeah, sir. In many of the studies, like by Patmala and Banerjee et al. 2021.
Anybody from marine side? Because on the land, see what happened on land.
Okay,
when you get forum, you say that it is a marine influence. Forum can come by other mean as well.
But the presence of certain marine diatoms as well as
see, just by because they are there on the land.
Sir, this has been observed along the coast, sir, in many other locations, like in the northern portion as well as in the many other lake regions.
Any study about sea level changes, not only by our group or some other group. 9.5 thousand back sea level as present level or even higher than present. What you want to say?
Sir. Sir, there has been a lot of studies regarding
which institute? Tell me.
Sir, I didn't get you.
No, which international study says 9.5 thousand years back sea level was higher than today?
Sir, I'm not.
Okay, think about it.
Yes, I will think about it.
Okay, Jitu, just one comment I want to make.
Yeah, please, sir.
If there are no other questions, once you are talking about Holocene monsoon, you need to correlate your data with the already established monsoon intervals. There have been several studies from the Arabian Sea
Okay, sir.
for the Holocene monsoonal changes, and the millennial scale studies are there, but I didn't find any of your curves correlating with the earlier works. So
Okay,
try
sir.
to correlate, because monsoon is a big phenomenon. It cannot be in a
Yes, sir. It cannot be that
local
local.
patch.
Yeah.
Okay, so you need to catch the intervals, or if you don't catch, then you should comment on that it is not correlate. Okay,
Okay, sir. Definitely, sir.
thank you, Jitu.
Thank you for the session, sir.
Next speaker is Deepanvita. Deepanvita, are you there?
Yes, sir, I'm here.
Yeah, please share your presentation. Deepanvita is going to speak on reconstructing climatic history through speleothems petrography. The abstract appears on page number 43 in the abstract one.
Should I share my entire screen?
Yes.
Select entire screen option.
It's not allowing me to.
Rahul, allow kar do bhai.
It is allowed from my side. If you want, I can share from my side if you want.
Okay, okay, you can share.
Okay.
Yeah.
Yes,
Okay,
please
so
go
I'll
ahead.
be, yeah, sir. So I'll be talking about speleothem petrography and how it can be related to the isotopic signal that is received from speleothems. So next slide, please. So to introduce, speleothems are deposited from carbonates due to their dissolution by meteoric precipitation, and the dissolved carbonate material is reprecipitated inside caves and in the form of some calcium carbonate minerals like calcite, aragonite. So this is to introduce speleothems. Next slide, please. So to talk about why speleothems are important to as a paleoclimate proxy. So we live, we are terrestrial animals, human beings are terrestrial animals, so the rainfall that is falling on the land is more affecting us. So to study that rainfall, speleothems are important, and also it is available in a lot of places, be it arid or humid climatic areas, it doesn't matter. Caves are present in a lot of areas, so we can easily get rainfall data from a lot of places and also correlate. And also it is underground, so it is not so much affected by surfacial processes, so chances of contamination is less, and it can be precisely dated using uranium thorium method. And the isotopic composition of rainfall is directly reflected in the speleothem if we do the delta 18O study from that. Next slide, please. So here is an example of how speleothem is useful. So in the first graph, it is seen that age versus the delta 18O value has been plotted along the length of a speleothem. So it clearly shows that the times when it was wetter periods and the drier times. So if we go towards more negative delta 18O values, it usually represents wetter periods, and the less negative ones represent drier period. So by studying all these, we also can find climatic events like the Maunder minimum, and also it is well known that the 4.2 kiloyear event is also been has also been discovered from speleothems, so which led to the downfall of Harappan civilization and other civilizations. So this is an example of how speleothem is useful for paleoclimate studies. Next slide, please. So a lot of factors affect the delta 18O signal that we finally see in the speleothems. For example, the distance the moisture has traveled that produces the rainfall, and the temperature, the amount of precipitation that has happened along the way, Rayleigh fractionation, and all of these things. The nature of the bedrock through which the rainwater is dripping. So if the bedrock is not so much permeable, the signal will delay. So the rainwater will take time to percolate and produce the speleothem in a much later time. So the lag will be present. So in a lot of ways, this is how the delta 18O is affected. Next slide, please. So coming to my topic, I'll be talking about petrography. So we can look into a lot more finer details using the petrography. For example, the drip rate and the chemistry of the water at the exact time. So in this presentation, we'll be looking to the different microfabrics that is observed and how these microfabrics develop, and how is there any relationship between the isotopic signals and the microfabrics. So this is the sample image that I've shown at the site, and this has been divided into 6 pieces, and slides has been made from all of these pieces, and we'll gradually look into the petrography of each portion. So next slide, please. Okay, so the first to introduce everyone to how the petrography is identified. So this is a list of all the different type of textures that can be seen according to Frisia 2015. So, and you can also see that there is a coding side by side starting from 1 to 12. So this coding starting from 1 to 12, it actually gradually moves towards a higher mg percentage in the drip water, and also therefore it also denotes progression towards a drier climate, and also from a stable to a more unstable drip condition. Next slide, please. Okay, so here from the sample, the last 2 portions of the sample has been displayed as slide over here. So it has been named F and E. The lowermost part is F, and on top of that is E. So from each of the slides, I have selected 3 petrographic images as representatives. So in the first figure, in figure 1 of slide F, you can see a dendritic fabric that represents a very irregular drip pattern, and it is usually represented. It usually forms during dry conditions, because that is when drip rate is irregular. Also, the Mg content is higher. And similar for the next in figure 2, also we are seeing dendritic fabric, and in the figure 3 of slide F, we see columnar fascicular optic fabric, that is also known as CFO, and that also represent dry condition, not only because the Mg content is high, but also the drip rate is low for this type of texture to form, and also a lot of impurities need to be present so that the crystal splits like that. So if you can see the image, maybe you can see that the crystal are needle-like acicular type, and they're radiating from a central point. So to form this type of texture, impurities is needed, and that helps in the crystal splitting so that this texture forms. And in the next column and in the next row, we see in the slide E figure 1, we see columnar type of fabric that comprises of parallel crystals, and this is usually formed in the during wet conditions when there is a constant drip rate. The Mg percentage is lower, and that enables the crystal to develop very nicely. It is quite analogous to igneous rocks. When we see that there is enough time available for crystal growth, crystals usually develop very nicely. And same for the next 2 pictures, we also see columnar fabrics, and therefore in the slide E, we can say that there has been a wetter period during this during the deposition of this part of the sample. Next slide, please. So we're moving on to the middle two slides D and C. So here also similar type of fabrics are visible that I described in the last slide, and having similar type of conclusions. So next slide, please. Okay, so we are coming to the topmost portion, and here in the slide B, that is figure 1 over here, we again see columnar fabric that represent a constant drip rate and a wet period, and it changes next to the columnar fascicular optic, which represent dry period. So within a same slide, there are different type of textures observed as the crystallization progresses. Different type of climate is
Deepanvita, try to conclude now.
okay, and in the topmost slide, we find a different type of texture that I haven't described yet, and that is columnar radiaxial fibrous. It develops from the base of the laminae. The crystals converts into a point that is opposite of the CFO fabric that I displayed earlier. Next slide, please. Okay, so here is the delta 18O profile of this sample, and side by side I've kept the petrographic profile also. So you can see that during the wetter periods, the petrography also more or less agrees with that. So in the wetter periods, we can see the fabrics such as columnar open, columnar elongated, columnar compact that usually forms in wetter periods, and all. And during the drier phases, we find the textures that are developed during the drier periods. But it is not absolute, because it more depends on the drip rate. So even during a dry period, there can be a high drip rate phase. So if you find a columnar fabric during a dry period, we can think about the drip rate during that time. So that is what I had to say. Thank you.
The talk is open for discussion. Any questions from the audience? Naresh, please. Oh, sorry, Dr. Pant. Your name is coming as Naresh, so I thought Naresh. No.
My name is Naresh, so that is why it is coming as Naresh.
Yeah.
And yesterday somebody told you also my full name, na Birja or something.
Yeah, I came to know for the first time. Yeah.
Okay.
Please go ahead.
Yeah. So I was. It's interesting. You presented some petrographic features. I don't have a question actually. I have a suggestion. When you are when you are showing that there is a let us say desiccation related layering which is leading to, let us say, higher magnesium in the end product. Now that can actually be supplemented if you, and it is a speleothem, it is a very slow process. So what I suggest is that if you have an elemental mapping done for these petrographic features, and there is a zoning kind of thing which you see successively in successive layers, that will be supporting, that will be strongly supportive of what you are petrographically interested.
I actually maybe missed saying that it is actually the Mg percentage in calcite. So all of these are still in the low Mg calcite phase, but progressively the Mg percentage increases as.
Yeah, but that is what I'm saying, that the variation with successive formation can be best exemplified by supplementing the petrographic data with an elemental mapping.
Yeah, that's a really good idea. I will definitely try it.
Okay.
So
what is
the
width indicate what? The width of layer in speleothem, you say thicker width or thinner. What they also indicate climate?
Thin and thick layers actually represent the amount of water flow.
Yeah,
if there is more dripping is more than thicker films, thicker layers will develop.
And this is what you also concluded with all your petrographic studies, that when it was wet and when it was not that much wet. Why I have to do all these things just to find out what is the portion of when it have a better climate?
Yeah, actually, work is still going on. I still need to think a lot of things about it. It is only a preliminary. I will think about this also.
Just think that your tool, what additional information can give, which
Yeah,
such a simple
actually,
tool like changes
actually,
can
it's
give
not
you.
even. Yeah, it's actually not even fixed that only dry condition will produce a fabric like dendritic. So it's not totally exactly well, correlatable, perfectly correlatable. So a lot of things have to be thought about.
Okay, good, Pooja. That is a very good attempt that you are trying that even the texture of the speleothems can be used as a proxy for climate, though you are not sure, but this is a good thing that you are establishing new proxy. Only with time you will be able to know more details about it. So
Thank you,
thank you
sir.
for your presentation. You can stop sharing your slide. Next presentation by Dr. Meenakshi. Are you there, Meenakshi?
Sir, actually, she just mailed me that she'll not be able to give the presentation because her laptop is not working.
Okay, no problem. Then Neha, are you there? Next presentation by Neha.
Yes, sir. Yes, sir.
Neha, are you ready?
Yes, sir. I'm sharing my screen.
Okay, so Neha will present on paleopedological evidence of the early Oligocene monsoonal condition. And the abstract appears on page 45 of the abstract volume. So Neha Upreti, Rohit Kumar, Abdul Hamid, Pooja Yadav, and Pankaj Srivastava. So Neha will be presenting. Neha, you present it in 10 minutes, please.
Yes, sir.
I also request Dr. Birja Das, who is the rapporteur of this session,
Yes, sir.
to please keep on noting. Yeah.
Yeah, I'm noting,
Yeah.
sir. Yeah, thank you very much.
Yeah,
Yes.
you are my BHU friend, so you will help me.
Definitely, sir. I'm sorry to say I'm not your friends, I'm your student.
My all students are my friends.
Should be.
Thank you very much. Okay.
Sir, is my presentation is...
Yes, please go ahead.
Okay, sir. Okay. Good evening, everyone. The topic of my presentation is paleopedological evidence of the early Oligocene monsoonal condition over the Indian subcontinent. The monsoon seasonality, the monsoon, which is represents one of the Earth's most dynamic interaction between the atmosphere, ocean, and continents. The knowledge based on the previous research suggested that the inception of the monsoon over the Indian subcontinent occurred during 23 to 22 million year, and it is further got strength around 11 to 8 million year. Okay, however, its onset and timing are debatable, and there is a strong possibility of older monsoonal condition during the early Oligocene. In our study, we are trying to fill this gap of knowledge by using paleopedology of the sediments from Kangra subbasin. Uh, as we all know, the collision of the Indian and Eurasian plate took place at about 55 million year, which has resulted in the formation of the Himalayan orogeny and the northward drift of the Indian plate and its paleolatitudinal history for our study area, which is located at 29 degree north, 88 degree east at present, and shows that it was located at 5.5 degree north at 55 million year, which is shifted towards 20 degree north at 30 million year, and 23.3 degree north at 20 million year. The geological history of the Earth for the last 65 million years shows significant climatic changes such as greenhouse to icehouse transition and the establishment of modern climatic condition in response to orbital forcing and tectonics. At the global and regional level, this time period is very important because the northward drift of the Indian plate, the shrinking Tethys, and the Himalayan orogeny affected atmospheric flow and climatic condition in a major way with the establishment of the modern land-ocean distribution. The Himalayan foldland basin is the largest terrestrial foldland basin in the world, which and the sedimentation here is spanning from early Oligocene to Holocene time. The northward edge of the Himalayan foldland basin was deformed by fault propagation, folding with a shortening of about 23 km in the northwest Himalaya. And the perturbations and the sonicity of the main boundary thrust resulted in the formation of several reentrants and salient throughout the Himalayan foldland basin, such as the Kangra subbasin and Subato subbasin. My work is on Kangra subbasin, and the Kangra subbasin is one of the largest basin in the Himalayan foldland basin, which occurring as a 90 kilometer wide U-shaped convex to the northeast structure, and it is characterized by the folded sedimentary sequences of Dharamshala and Shivalik in the north and the vast Indo-Gangetic plain in the south. My study utilizes red paleosols of lower Dharamshala and yellow paleosols of the upper Dharamshala, which are exposed along the J&K section. A total of 11 lithosections for the entire 3.1 kilometer thick fluvial succession were mapped and studied in detail for key macromorphological features by using Soil Survey Staff 2014. And for micromorphological studies, large thin sections of these paleosols were prepared by following procedure outlined in Murphy 1986 and examined by following the guideline by Stoops 2014. And for the clay mineralogical study, these paleosol samples were analyzed for total clay and fine clay after using Jackson 1979. Now coming to the field description. The 3.1 kilometer thick terrestrial sedimentary record of lower and upper Dharamshala formation shows the fluvial succession with mudstone and sandstone facies. At the base of this terrestrial record, approximately 200-meter thick white sandstone defines the transition from marine to continental sediments, and the 2-kilometer thick fluvial sediments of lower Dharamshala formation, which are characterized by the red paleosol. And the upper Dharamshala formation contains the yellow paleosol in the upper 1.1 kilometer section. In the lower Dharamshala formation, the sandstone occur as 1 to 10 meter scale channel bodies that are single to multi-story in nature, whereas in the upper Dharamshala formation, the sandstones are defined by medium grain, and multi-story sandstone bodies are also present in upper Dharamshala formation. In upper Dharamshala formation, these type of multi-story sandstone bodies are very common than in the lower Dharamshala formation. So the degree of pedogenic development, thickness, and the relationship of different horizons in the red and yellow paleosols confirm the presence of 4 pedophacies type A to type D. And the paleopedological features of the 4 pedophacies in red paleosols, which are from lower 2 kilometer, and pedogenic development over the entire lower and upper Dharamshala formation of the Kangra subbasin of the Himalayan foldland basin. The paleopedogenic feature in these red paleosols and yellow paleosols are similar to those in late Quaternary paleosol and modern soil of the Gangetic plain. The red paleosols here are similar to their stratigraphic equivalent Dakshai formation in the adjacent Subato subbasin, which suggests that weathering and the formation of ferruginous paleosol occurred over a large area and interval of time during the Oligocene. Now coming to the micromorphological part, the micromorphology of red paleosol shows the moderate to strong pedality with some impure clay pedofeature, pedogenic CaCO3, and some biogenic activity with some root traces. The pedogenic CaCO3 is commonly found in these red paleosol with the formation of BK and BTK horizon. The micromorphological detail of these pedogenic CaCO3 suggests the prevailing seasonality during early Oligocene because they are showing the dense impure micritic nodules with diffuse boundary, dissolution and reprecipitation features, calcite concretions with thin iron oxide and alluvial clay coating, and distribution of the pedogenic CaCO3,
Neha, you have only 2 minutes left.
which present in more than one horizon of the red paleosol. Let's see there. In the upper Dharamshala formation, the thin sections shows the stress clay coating, large root channels, and thick pure clay coating along the void and the ped wall. In a clay mineralogical part, both yellow and red paleosols include smectite, vermiculite, chloride, mixed layer mineral, both elite vermiculite and elite chloride, elite and kaolin, with the presence of quartz and feldspar. A semi-quantitative estimate of the clay minerals of red and yellow paleosols and their variation with depth in the lower and upper Dharamshala formation are presented in this figure. The red paleosols are characterized by the presence of elite, chloride, kaolin, and elite vermiculite mixed layer. The kaolin shows an increase upward in different horizons of the profile, whereas the chloride and elite chloride show an increase in the BT horizon in comparison with BW and BC horizon. An overall comparison of the variation of the clay mineral in red and yellow paleosol of these succession shows that the lowermost part of the succession is marked by the absence of any discrete smectite and vermiculite, but the occurrence of a large amount of chloride and elite. And the smectite and vermiculite appear near the transition from red to yellow paleosol, which is at about 20 million year. There is an increase of kaolin from 3 to 28 from lowermost to uppermost part of the Dharamshala formation. The elite vermiculite interstratification is more common than elite chloride in the red paleosol.
नेहा प्लीज भी क्विक करना.
Yes sir, conclude कर रही हूँ sir, final है. Based on our research, this suggests that the inception of the monsoon over the Indian subcontinent occurred during 23 to 22 million year and strengthened about 11 to 8 million year. But there is a possibility of monsoonal condition during the early Oligocene because modern land-ocean distribution was well established during the early Oligocene at 34 to 30 million year. And this phase is also marked by a marine to continental transition and the oldest continental sedimentation in the Himalayan foldland basin. The tropical barrier, due to the rising Himalayas, influenced atmospheric circulation over a large scale, and this orogenic versus topographic growth due to India-Asia collision suggests that the moderate relief mountain, which were 2,000 meter high during the early Oligocene, they attain higher elevation, approximately 4,500 meter during the late Miocene. So rise of the Himalaya changed the climate more towards continental condition with increased seasonality. And
can you conclude, Neha?
Yes, sir. Conclusion here.
Yeah.
The current study proposes the enhanced precipitation during 20 to 13 million year, and the paleopedological evidence of the Asian monsoonal system presented in this study is in agreement with the recent reports based on multi-proxy records of monsoon intensity that indicate that the summer monsoon rains were weak prior to 24 million year, but became progressively stronger with a peak period from 15 to 11 million year. The paleopedological record of seasonality presented here is also consistent with the temporal correlation between the predicted topographic growth and the monsoon intensity that indicates a Miocene strengthening of the Asian monsoon as a product of subduction dynamics. In terms of tectonic deformation versus topographic growth and rise of the Himalayas, it is also in agreement with the studies related to high pressure metamorphism that occurred as early as 38 million year and locally persisted until 15 to 13 million year.
Thank you, Neha. The talk is open for discussion. We can take one or two questions. Okay, so I don't think there is any question. So Neha, I was listening to your talk.
Yes, sir.
And in the preamble, you said that many people have said the onset of Indian monsoon, some at 8 million years, some have even come out at 5 million years. And there have been various dates. But as you said, that is the Oligocene, early Oligocene study.
Yes, sir.
That's very interesting because, as you have shown in your conclusion slide also, the Eocene Oligocene boundary or start of the Oligocene, worldwide we have OI1 event and then OI2 event where the marine benthics have a positive excursion in delta 18, showing the initiation of the Antarctic ice sheet. So that definitely would have changed the kind of atmospheric circulation and the boundary conditions which we had earlier before early Oligocene. So I find your study has a lot of importance if you come out with more precise chronology and could relate the paleosols and the climate with this global event of OI1 and OI2. Though your range is a little bit coarse, but I think that with time, this record will become very, very important from the Indian continent.
Sir, just to add, if you wish, this paper is already there. Just few months back, it is there in published in Sedimentology now, and a lot of information is already there. And we're the first to describe this kind of monsoonal activity prior to this 20 million years of general consensus, and a lot of markers are present here. In fact, after this, there are several people are trying and they're writing from different regions of the world, from Myanmar, from China. They are saying no, monsoon is much older than 20 million years and they're coming up. So this paper is already there and we are still trying to work it out from the geochemistry and isotopes and all that.
Okay, thank you, Pankaj. We have next paper by Naina Haridas.
Hello, sir. Am I audible?
Are you ready?
Yes, sir. Am I audible?
Yes, you are audible. We want you should be visible also. Naina Haridas will speak on paleo-monsoon reconstructions from Bay of Bengal sediments since last glacial maximum. And the abstract appears on page number 46 of the abstract volume.
Sir,
yeah, please go ahead.
is my screen visible now?
Your screen is visible. go to the slide presentation mode. Yeah.
Now it's
You
fine.
can start now.
Good evening. I'm Nayanadi Haridas. I'm working as a MOS JRF in National Center for Earth Science Studies. My presentation is on paleo-monsoon reconstruction from Bay of Bengal sediments since last glacial maxima. Paleo-monsoonal study deals with the study of past monsoonal variation since the instrumental records does not go beyond last 2 centuries. Natural archives such as corals, tree rings, ecotherms, sediment cores are used for paleo-monsoon and paleoclimatic studies. Among the sediment cores, marine sediment cores are used as an important proxy because marine sediments remain undisturbed compared to the continental records. And in my research, I have focused on the marine sedimentary records. Indian monsoon is a dynamic climate system which causes large-scale precipitation, and it affects the agricultural and socio-economic development in the Indian subcontinent and the nearby region. Indian monsoon consists of Indian summer monsoon and Indian winter monsoon, and Indian winter monsoon comprises of western disturbances and northeast monsoon. Indian monsoon is caused by the lateral migration of intertropical convergence zone, and ISM is caused by the northward shift of ITCZ, and it causes greater than 70% of precipitation over the Indian subcontinent, whereas northeast monsoon is caused by the southward migration of intertropical convergence zone, which causes majority of precipitation in the eastern coast of India and northeastern region, and it triggers the peninsular riverine influx. The Indian subcontinent, which is surrounded by two subbasins, which are Arabian Sea and Bay of Bengal. Both these subbasins are almost located in the same latitude, but they exhibit distinct characteristics in terms of temperature, salinity, and productivity. Bay of Bengal is characterized by fresher surface water, saline stratification, intense rainfall, and low productivity compared to the Arabian Sea. And Bay of Bengal is the northeastern extended arm of Indian Ocean, which is a semi-enclosed basin with highest fluvial and heterogeneous input. And the major river sources to the Bay of Bengal are Himalayan and Peninsular rivers, and it constitutes an area of 2.2 million kilometers square with an average depth of 2,600 meters. Several ocean currents operate in the Bay of Bengal, and it reverses its direction due to the seasonal reversal of monsoon wind. East Indian coastal current, which is a major ocean current in the Bay of Bengal, and it flows in clockwise direction during the summer monsoon, and it flows in anti-clockwise direction during winter monsoon. The specialty of Bay of Bengal is it's a unique basin that witnessed both the effect of Indian summer monsoon and northeast monsoon. Several studies has been carried out comparing the proxy records from Indian subcontinent and adjoining region, but exclusively focusing on Bay of Bengal sedimentary record addressing Indian monsoon variability or less. Thus, my objective is to address the Indian monsoon variability since last glacial maxima from the sedimentary records of Bay of Bengal, and I have selected past 20 kilo year because during this time interval, several climatic intervals has been observed. Last glacial maxima, which is the most recent climatic deglaciation that has been occurred during the late quaternary time period, and Hendrick events, boiling Ellerod, younger dries, and Holocene are other climatic events that have been visible during the past 20 kilo year. In order to address the objectives, we have selected studies from Bay of Bengal. We have collated more than 30 studies exclusive from the Bay of Bengal, and we have broadly categorized into Northern Bay of Bengal, Western Bay of Bengal, Eastern Bay of Bengal, and Southern Bay of Bengal. From the Northern Bay of Bengal sedimentary records, the magnetic susceptibility and in situ productivity proxy studies suggested that during last glacial maxima, an intensified northeast monsoon has been observed along with simultaneous weakening of ISM. And during LGM, an increased peninsular riverine influx has been observed, which could be due to the intensified northeast monsoon. And similarly, during last glacial maxima, a sea surface temperature has been decreased by 2 degrees Celsius compared to the present day. And similarly, a study by Kudras et al. Based on the stable isotopic study on foraminifera, during LGM, the enriched delta 18 values indicate that ISM was weakening, and during the Holocene time period, the depleted delta 18 values indicate that ISM strengthening. And from the Southern Bay of Bengal sedimentary records, during the time period from 5 to 7, 14, 19, and 25, intensified northeast monsoon has been observed. It could be due to the intensified northeast monsoon. It could be during that time, Irrawaddy river input has been dominant. And during last glacial maxima, the sediment input from Ganges Brahmaputra has been reduced. And the reason could be due to the ISM weakening. and sea surface temperature has been reported to be shown at degrees of 3 degrees Celsius. And during Holocene, enhanced solar insulation together with ISM strengthening has been observed from the southern Bay of Bengal sedimentary records. From the western Bay of Bengal, based on oxygen isotopic and MG/Sa measurements in planktonic foraminifera, they have suggested that cooler sea surface temperature has been observed during LGM, and a sediment core from western Bay of Bengal, based on the sediment provenance study, they have estimated that the sediment contribution from Himalayan river, especially from Ganga river, has been reduced by 30% during LGM, which could be the result of ISM weakening. And during boiling Alarod period, the sea surface temperature, that is around 14.7 kiloyear, a rise of SST by 1.4 degrees Celsius has been reported, and together with depleted delta 18 values during this time period indicate strengthened ISM. Later, during younger Dryas, a decrease in SST has been reported, along with the enriched delta 18 values indicating weakened ISM. And during early Holocene, delta 18 depleted value indicate that strengthened ISM, along with extensive rainfall in the Ganga, Brahmaputra, Meghna river catchment. And during late Holocene time period, ISM weakening, which suggests drier climate during this time period. From the eastern Bay of Bengal sedimentary records, a stable oxygen isotopic study on foraminifera has revealed during LGM, evaporation has been higher, and SST has been reported to be like 3 degrees Celsius cooler during last glacial maxima. And Irrawaddy, Salween, and Sidgone rivers are a major rivers that are debouching freshwater and sediments to the Andaman Sea. And during LGM, the freshwater discharge from this river has been decreased, while during early Holocene time period, the discharge from this river has been increased, suggesting strong ISM. Similarly, Panda and Mishra, based on an isotopic study in clay sediments, they have reported that during LGM and younger Dryas, ISM weakening, and during boiling Alarod and Holocene, strengthened ISM has been reported. Most of the studies has demonstrated intensified northeast monsoon with a simultaneous weakening of ISM during LGM. During the LGM, similarly, a decrease of SST compared to the present day has been reported. During the boiling Alarod period, strengthening of ISM is reported, along with a rise of sea surface temperature, whereas during younger Dryas, weakening of ISM is reported, along with a decrease in sea surface temperature. And during early Holocene time period, along with enhanced solar insolation, ISM intensification has been reported, and during mid-late Holocene, along with the decrease in solar insolation, gradual weakening of ISM is reported. And most of the studies doesn't demarcate the climatic condition during Hendrick events, which could be due to the low sample resolution. But few studies have reported that ISM weakening during this time period. And a sediment provenance study at different location of Bay of Bengal could be extensively studied, since it can provide information of the monsoon system, as the geology of the river basin debouching to the Bay of Bengal are distinct, and it witness both monsoon in varied intensities. Thus, the northeast monsoon and ISM interplay could be better resolved by more in-depth study from Bay of Bengal sedimentary records.
The talk is open for discussion. Please unmute yourself, Dr. Nigam.
See, basically, this is a review paper, isn't it?
Yes, sir. Yes, sir.
Have you come across any paper by Rajni Panchal from the Myanmar side of Bay of Bengal?
Rajni Panchal. No, sir. Yes.
Okay, I can tell you the paper is in marine geology.
Okay.
Okay, Paleontological Society of India.
Okay.
And I think probably one paper in some other journal where they talk about the tectonics also during the Holocene along the, and as well as all the minima what you're talking about, all the events.
Okay.
Okay, so next time when you are doing review, include that paper.
Okay.
And not only her paper, there are other papers as well from Myanmar side, since you have covered the eastern and western both. From NIO group, Ramaswamy, P.S. Rao, they have published a lot of paper and are in an international journal. We have not cited any one of them.
Okay, I will go through it. We were like entirely, we were focusing on the monsoon.
Okay, because they are also each of this paper talking about the monsoon.
Okay, I will go through it, sir.
Okay, and the river flow from Irrawaddy and other
Irrawaddy,
things.
okay.
Okay. Actually, which paper from NIO, any sign you have cited from Bay of Bengal?
Hello, sir.
Out of the paper which you consulted, which is the paper appearing from NIO? Any paper you used from which is published by NIO scientist?
I'm not sure what the Penmay et al.
Okay, Naina, just
Yeah.
There is a bunch of
consideration of its
plenty
suggestion.
of papers from Bay of Bengal. Please
Yeah.
include them.
Okay, sir.
Yeah, there are so many papers. Naina, you need to look at those papers because any research should be based on what has been done earlier and you should be able to correlate also.
Okay.
I have only one small comment to make for all monsoon worker, including you. Say, whenever you correlate your summer monsoon with North Atlantic, so why don't you consider your immediate neighbor? You have excellent records of the ice core from Antarctica for last 800 kilo years. It is available. But whenever I see any record from the Indian monsoon, you say during LGM it weakened, during younger dryas it is weakened, during warm event it increased. Now one slide all of you should devote to show that why younger dryas should weaken our Indian summer monsoon. And if younger dryas, thousands of kilometers away in North Atlantic, can weaken your Indian summer monsoon, then what about Antarctic warm events? Say in marine isotope stage 3, you have AIM events, Antarctic isotopic maxima, and they have been very well correlated with the Chinese lowest deposits. And Indian monsoon teleconnections with Antarctica is very well established. But all these studies completely forget so big a continent which is our next neighbor. There is no land even between India or Indian Ocean and Antarctic. So this is my one suggestion that
Yes, sir.
we should also talk about physical mechanism connecting the younger dryas or LGM with the Indian summer monsoon.
Okay.
And if you look at it, it is all the play of heat reservoirs, distribution of heat. Thank you.
Okay, sir.
So we go to the next presentation if there are no questions. Next is by Upasana Banerjee. Are you there, Upasana?
Yes, sir.
Are you ready?
Hello. Yes, sir. Should I share my slide?
Yes. Upasana Banerjee will speak again on Holocene climatic variability and Indian summer monsoon linkage to global climate events. So maybe I have already gave my comments for the next presentation also.
Sure, sir.
And her abstract appears on 47 page number 47 in the abstract volume. So Upasana, you can start your presentation. So you are thanking us.
Sorry. So is my slide visible? Hello? Hello?
Yes, it is.
Yes, it is visible. Please go ahead.
Please
Yes.
hide that tab at bottom.
Okay, sorry. Good evening, respected chairman, delegates, and my dear friends. After the long saga of human interaction, one thing that we humans have realized is we are just the custodians and not the owners of the earth. And thus the need for reconstructing past climate and documenting several climatic events has become extensively necessary, not only to understand the present climate scenario, but also to project the future climatic trends. In view of this, I, Upasana Banerjee from National Center for Earth Science Studies, would like to give a talk on Holocene climate variability and Indian summer monsoon linkage to global climatic events. Well, this is going to be my plan of talk, where I'll begin my talk with some introduction, followed by its objective, then Holocene climate variability and possible natural forcing. I'll end my talk by giving some inferences. Of course, my colleague Naina, she already discussed about ITCZ, but for the sake of completeness, the ITCZ, the Intertropical Convergence Zone, is basically a narrow latitudinal zone of wind convergence and precipitation that determines the onset and duration and termination of the rainy season. And the ITCZ generally shifts from 9 degree north to 2 degree north over Atlantic and Pacific Ocean, but a drastic migration over Indian subcontinent and northern Indian Ocean is observed. That is around from 20 degree north to 8 degrees south during boreal summer and boreal winter respectively, and which leads to Indian summer and Indian winter monsoon. Well, Indian summer monsoon causes more than 70% rainfall, and Indian winter monsoon, basically it is of two types, the westerlies and the northeast monsoon. The westerlies mainly affect the northern Indian region, whereas the northeast monsoon is influenced along the southeast Indian coast. Since our Indian subcontinent experiences such a variable kind of monsoon, several pioneering work has been conducted to reconstruct and understand the Holocene climate. And recently, the Holocene climate or the Holocene epoch has been broadly divided into North Greenlandian stage, Greenlandian stage, North Greenlandian stage, and Meghalayan stage, based on two abrupt climatic events, the 8.2 kiloyear event and the 4.2 kiloyear event. Moreover, the Holocene epoch has also been several bond events has also been observed within the Holocene epoch, ranging from 0 to 9. And these bond events are basically identified as the cool phases, which has been linked with the reduced thermohaline circulation in the North Atlantic region, wherein the bond event 3 and bond event 5b are associated with the two abrupt events that of 4.2 and 8.2 kiloyear event. And two major natural forcing which acted during Holocene are solar forcing and the volcanic forcing. Of course, some anthropogenic forcing are also there, which acted during last 200 years. There has been several, which means there are several abrupt climatic events identified during Holocene epoch, and India and Indian climate or the climate of India has varied as a function of changing monsoon variability. But the response of monsoon towards these global climatic events are still poorly understood. In view of this, the objective for my today's talk is to understand the response of monsoon variability towards such global climatic events during Holocene and during the last millennia. The reason for last millennia is because it acts as the frontier for understanding the present climate and future projections. We collated some of the marine and continental records, and we compared it, wherein the 4.2 kiloyear event is observed or recorded in both marine and continental records in the form of ISM weakening period. Whereas in case of 8.2, yes, the marine records have registered 8.2 kiloyear event. But in case of continental records, in case of continental part, the northern region, the northern, the northern, yes, the northern Indian subcontinent, northern India region has significantly registered 8.2, especially the region which witnessed the northern extent of ITCZ has found to be more sensitive towards 8.2 kiloyear event. Looking into the bond events, both the proxies have responded towards the bond event. However, the bond event 6, 7, and 8 has been missed by continental records, possibly because of the limited extension of the proxy. Now, the reason for what must have caused such Holocene climatic variability. So, during the Holocene, there is a gradual reduction in the solar insolation, which is observed, and simultaneously there is a simultaneous increase in the El Nino events during the Meghalayan stage, and the gradual solar insolation, decrease in the solar insolation corroborated well with the gradual southward migration of the ITCZ. That means the gradual southward, the declining solar forcing triggered the ITCZ migration towards south, which in turn instigated the El Nino events during Meghalayan stage, and thus we received limited Indian monsoon with the towards Meghalayan stage. Looking into the last millennium, the climate of last millennium is broadly divided into three: the medieval warm period, the little ice age, and the modern warming. The climate transition of medieval warm period and little ice age, several factors has been found to be responsible, such as the solar forcing, the volcanic forcing, and the little ice age is also famous for the frost fair over River Thames. And here you can see the frost fair painting of the frost fair, and the modern warming, which occurred during last 100 or 150 years, and it is definitely.
Upasana, try to conclude now.
Sure, sir. So we also collated all the climatic records for last millennia, and what we observed is the medieval warm period has been warm and wet as a result of ISM strengthening. But in case of little ice age, heterogeneity has been observed, wherein the northern Indian records have shown wet climate due to increased winter precipitation, whereas most of the peninsular region have shown dry climate as a result of ISM weakening. So we also looked into the global records, and what we saw is a volcanic eruption of around 700 corroborated with the gradual decrease in the temperature, and from that point a gradual southward migration also occurred for ITCZ, and the ITCZ shifted to its southernmost part during little ice age. So the southward migration of ITCZ led to the increased winter precipitation over northern India. So inferences drawn from the study are the ISM strengthening, the ISM strengthening with gradual declining trend is observed during Holocene epoch, which corroborated with the declining solar insolation. The weak ISM during abrupt climatic events like 8.2 and 4.2 is observed, and along with the little ice age. Whereas,
okay, you can leave this conclusion slide for
the
audience, and I will invite the discussion now. If anyone has any question, please raise your hand, or you can directly ask the speaker.
Upasana, have you come across any paper where they talk about cyclicity in last millennia?
Cyclicity, yes, sir.
Which area? And can you just elaborate?
So, like by Agnihotri et al. In Eastern Arabian Sea, Southeastern Arabian Sea, where he has talked about the cyclicity of nearly 60 years, which corroborates with the Indian monsoon.
Have you come across Glesberg cycle also?
Which cycle?
Glesberg.
Yeah, you're talking about, yes, sir. Glesberg cycle, solar cycle.
Cycle.
These are all Eddy's cycle. These are solar cycle, I believe.
Because you have not, you talked about solar insolation, but you didn't talk about any of the cycles. Number of cycles have been reported from both Arabian Sea as well as Bay of Bengal.
Yes, sir. Actually, I have broadly shown the solar forcing, but I have not discussed about the cyclicity, because the other volcanic event has also resulted in the last millennium.
And your first statement for Arabian Sea or for Bay of Bengal, out of your inference, first statement?
1 second, sir. First statement here, inference?
Yeah, this one.
It is the overall scenario I have discussed. It includes both a continental record also, because in Lunar Lake also they have seen a gradual decline in the ISM during the entire Holocene.
Okay, Upasana.
Yes, sir.
Since there are no more questions, let me make some observations.
Yes, sir.
You see, what Dr. Nigam was telling you about the studies which have already been made.
Yes, sir.
I see that whatever you have done, it's not, you have not generated any data.
Yes,
You
sir.
are just presenting some review.
Yes, sir.
So in this type of review, you need to have some kind of a protocol.
Okay.
Since you are telling that 8.2 kilo year recorded in marine record also, what is marine record? My goodness, you cannot say marine record. Marine record, do you mean this North Atlantic, South Atlantic, Indian Ocean, Eastern Pacific, Western Pacific? You have to specify. This is not the way.
Sir, one second. This is Northern Indian Ocean records.
Yes.
Yes, sir. That is already
Yeah,
mentioned.
marine record doesn't mean. Then second thing is,
Yes, sir.
whenever you correlate, I also commented on the previous presentation. Whenever you correlate with global events, always remember the phase lag.
The phase lag is there.
Phase lag. There are certain standard methods to correlate. Say, if you look at bipolar seesaw, the Tansgar-Ashgar cycle, which is very well recorded in the Greenland ice core,
Grip ice core, yes, sir.
Grip ice core, they are represented by warm events in Antarctica.
So because of the hemispheric
I am
changes.
not asking you why it is. They are recorded as warm event in Antarctica, and there is a theory behind it, but that is not established about the Southern Ocean heat reservoir. Now, once it is happening in North Atlantic, the Henrik events, the younger dryas, suddenly you are finding in tropical Indian Ocean, and then immediately correlating that during the younger dryas, this happened, that happened. If you have an idea of polar amplification, you will know that the global average climate change is represented by 4 to 5 times amplitude in Arctic and 2 to 3 times in Antarctica. And many a times, the polar amplification where we catch the North Atlantic, younger dryas, Henrik events, we blindly correlate with the notches and wiggles of our curve that this has happened because of that. A coincidence is not a correlation. If you have a correlation, that means you need to explain why such things happen. It's still with thousands of papers, people have not been able to explain the bipolar seesaw. But I see frequently Indian workers from the coast of India immediately correlating with younger dryas, LGM, global events. And my last comment is, whenever you talk about a local record of the monsoon from land-based section, remember it is the precipitation record. While you go for Arabian Sea, most of the time it is upwelling record. It is the wind strength. Wind strength and upwelling, if you correlate, the R value doesn't come beyond 0.6. So it is not always that the wind strength of the Arabian Sea will be translated into equal precipitation all over India. There is a patchiness. You read the paper by Anil Gupta et al., just published few months back, about the patchiness. That you can have a precipitation in one part of India, huge precipitation, but the other part, kilometers away, may be dry. So whenever you talk about precipitation, my humble submission is talk about precipitation in that locality. Do not talk about Indian summer monsoon. Indian summer monsoon is a very big thing.
But sir, here
it can only be talked if you integrate a number of land records, and only then you can tell about Indian summer.
So actually, this is actually a published work in Holocene paper where I've collated around.
This is not an argument that it is published work or not published work. Can you explain now why why younger dryas should result in weaker Indian summer monsoon?
So younger dryas, basically younger dryas witnessed low, poor thermohaline circulation. That is why the younger dryas occurred.
That is the problem. Younger dryas.
Then before
younger dryas was the cause of low thermohaline circulation,
okay,
or
so
low
then,
thermohaline circulation was cause of younger dryas.
One second, sir. Because before younger dryas, there was a warm period which resulted in the enormous freshwater influx into the sea, which led to the poor thermohaline circulation.
And it all happened in North Atlantic. Now, why it should be transferred to Goa coast or Kerala coast? What is that physical mechanism where Indian summer monsoon will have more rain or less rain? That is what is my point is.
So that's true, but because finally we are also getting monsoon from North Atlantic westerlies. That itself is from North Atlantic, I believe.
Then you are coming to now in Kerala coast, North Atlantic westerly.
So this is not nowhere we are discussing about the Kerala. It is just the collation of the studies, and
This
then
collation has a protocol. The collation has a protocol. You cannot have all the global records. I can tell you, you have paper from B.S. Kotlia.
Yes,
you see that during colder events, they show the increase in summer monsoon. It is published in Quaternary International.
it is that
Even in Little Ice Age also.
Little Ice Age, it was a westerly disturbances.
So that is what I am telling.
So that's
once
what
you
I
tell
said.
about Indian summer monsoon at present also, we are undergoing the monsoon seasons. And you can see the patchiness.
So, sir, there will be a variability over the latitudinal variation of ISM throughout the Indian
No, tell me
subcontinent.
about the Patna flooding. That is a precipitation record.
So
But
these are
it is
the
not elsewhere.
No, sir, sir, it is because these flooding events are recorded various places within the arid event. Also, people have
You are
recorded.
not able to understand my point.
Okay.
Is Patna flooding because of Indian summer monsoon or not?
This is during summer monsoon. Yes.
It is. Just 3 days back.
Yes.
It rained, which is for last 23 years it has not rained like that. So these precipitation records are preserved. So but if you go beyond Patna, it is not preserved. So whenever you talk about precipitation record, please say precipitation record at a particular point. Okay, we can discuss it later.
Sure, sir. Thank you so much.
So we have next presentation now. You can stop sharing your slide. You have already done it. By Abdul Hamid Pooja Yadav on micro-morphological and clay mineralogical evidences of paleopedogenesis in 12 MA, 5 MA fluvial sediments. The abstract appears on page 48 of the abstract volume. So Abdul Hamid, are you ready?
Yes, sir.
Yeah, please start the presentation. You have 10 minutes.
Yeah. Am I audible?
Yes, you are. Should I start? You are audible. You can be seen. Start.
Okay. Good evening to all. The topic of my presentation is micromorphological and clay mineralogical evidence of paleopedogenesis in 12 to 5 million fluvial sediment of the Himalayan foreland basin in response to climatic change. As we all know that the Himalayan mountain range was formed as a result of collision between the Indian and Eurasian plate, which began at about 55 million years ago. The outer part of this range is marked by the foreland basin in the south, that resulted due to thrust loading subsidence with synorogenic sedimentation from the hinterland. in which the thick succession of Sivalik sediment has been deposited, which is bounded by main boundary thrust in the north and main frontal thrust in the south. That the Sivalik has stored the important information like the climatic change and hinterland tectonics with the weathering trends. Despite the important information on various aspects like tectonic, paleoclimate, sedimentology, and geochronology are now available in Kangra subbasin, but still there is a significant gap on paleopetrological details that could give the weathering trend, paleo environment, and seasonality. It is also has the multi proxy approach like micromorphology, clay mineralogy, bulk, and isotope biochemistry. It will also give the detailed record of the paleosol that range from 12 to 5 million of range during the formation. So the paleopetrology of the Himalayan foreland basin sediment is very significant on account of hinterland tectonic, that is reactivation of MCT and activation and reactivation of MBT, and intensification of fluctuation of monsoon and C3 to C4 transition, varying sedimentation rate. So here we can see the global deep sea oxygen and carbon isotope record. From in this our study follows global cooling trend after the massive warming, which is middle Miocene climate optima. Apart from hinterland tectonics, the several important information took place like Asian monsoon intensification and appearance of C4 grasses. So the major objective of my research work is to explore the paleopathological feature of this Sivalik group that could be useful to highlight the paleo-environmental condition, including monsoonal condition archived in foreland sediment of the Kangra subbasin. So this can be subdivided into following sub-objectives to study
Upasana Banerjee,
to
mute yourself.
We study the pedogenic variability of the paleosol from lower to middle Sivalik, characterization and designation of different paleosol horizons, micromorphological details for pedogenesis and weathering condition, the clay mineralogical study to comprehend climate change during the formation. So in this study, we have followed the methodology. We have followed three-tier approach like literature review, field method, and laboratory method. So it comes. This shows the geological map of Katlukhat study area that shows Katlukhat section of Kangra subbasin of northwest Himalaya. So the Katlukhat section is exposed north of the Jwalamukhi thrust, covering the lower, middle, and upper Sivalik. This shows the sample location from where we have collected the paleosol sample from lower Sivalik and middle Sivalik. This is the simplified litholog and phasage variation of Katlukhat section of around 2.7 kilometer fluvial record of channel and overbank phases. This shows an overall coarsening and thickening upward trend, which include lower Sivalik, middle Sivalik, and upper Sivalik. This is the representative outcrop section from the lower Sivalik of the paleosol profile KK5. This shows different paleosol horizons, which we have identified on the basis of field evidences and thin section studies. Here we can see in field evidences like rhizochreation and calcium carbonate along the beds wall. These are showing micro photograph of lower Sivalik that shows some pedogenic features like subangular blocky structure, clay coating along the void, and shrink soil features, calcium carbonate along the roots. This shows the re-precipitation and coarsening of calcium carbonate that indicates some diagenetic effect in lower Sivalik. and this shows some clay elevation, and this is the bovet shape bioturbation that indicates some reworking of ground mass. This is the representative outcrop section from Middle Sivalik, which is the KK28 profiles, and this is also the different paleosol horizons which we have identified on the basis of thin section and field method. Here we can see some glazing feature and some calcium carbonate nodules in hand specimen. This is the micro photograph that shows some strong subangular blocky structure which have some large void and vest-shaped structure, clay coating along the void and fragmented clay. This is the calcium carbonate precipitated along the organic matter, and this is the pedogenic calcium carbonate that shows some diffuse boundary and mottles. This is the board shape structure that shows reworking of the ground masses. This is the semi-quantitative estimate of clay mineral and XRD diffractogram from lower Sivalik and middle Sivalik. So here we can see the different peaks of D spacing value that correspond to some characteristics mineral. On the basis of these XRD diffractogram, we have done semi-quantitative estimate from representative paleosol profiles that give the some depth distribution and vertical variation from lower to middle Sivalik. Here in the lower Sivalik, the dominant mineral are chlorite and illite, but in the middle Sivalik, here we can see the dominant mineral smectite, which is red in color, that showing increasing upward trend after, especially after profile KK42, and so here kaolinite is showing decreasing upward trend, especially after KK42 profiles. So this variation indicate that the some more seasonal climatic change, especially after 8.25 kilometer, 8.25 million years. So the here are some key points from lower and middle Sivalik subgroup. That is, lower Sivalik, we have mudstone dominated sandstone with the ribbon and seed geometry sandstone. The paleosol are dark red in color, which have well developed pedo features, and the dominance of clay mineral which we have found in lower Sivalik is illite and chlorite. Whereas in middle Sivalik, the sandstone dominated mudstone has multi-story sandstone and few conglomerate in the middle in the upper part of the middle Sivalik. The paleosol shows ray paleosol bound mudstone which have moderately to well developed pedo features. In the middle Sivalik, the dominant clay mineral is smectite and kaolinite. Based on these studies, we have summarized some key points like the paleosol shows dominance of moderate to well-developed pedogenic features that have BW, BT, BK, BSS, and BC horizon with key pedogenic features. Micromorphology shows structural elements like B fabric, elevation, roots, bioturbation, and carbonate nodules related to warm and humid conditions. Pedogenic carbonate nodules and dense impure micritic nodules show their formation possibly occur during the monsoon condition. The clay mineral indicating the development of more seasonal climate starting at about 8 million years. The presence of smectite in the paleosol of different interval from lower to middle Sivalik subgroup shows some aridity, and absence of smectite and presence of dominance of kaolinite in different paleosol profiles shows humid to subhumid climatic condition. In the paleopedological information of the paleosol suggests a change from arid to semi-arid condition to subhumid humid condition at about 8 million years. It is in confirmation of the fluctuating monsoon, which is marked by the strengthening and increasing precipitation at around 7 to 8 million years. Apart from this, we will be doing XRF analysis to make this data robust for the support of climate change at 8 million years.
Thank you, Abdul Hamid, for a very timely finish.
Yes, sir.
The talk is open for discussion. Any questions from the audience? Well, I have a few comments, Abdul.
Yes, sir. Please.
As you are showing basically you are inferring the climate during the position of the Shivalik sediments.
Yes, sir.
Based on your horizons, which you have identified.
Yes, sir.
This study you should, in future, you should integrate.
Yes.
Because ultimately you are talking about the monsoon or humidity,
yes,
or some humid or arid, okay, which originates mostly from the sea surrounding India.
Yeah.
So there are a lot of records of the sea surface temperatures in the Indian Ocean and also in the Western Pacific, based on alkinone, MgCa, and oxygen isotope. And as you know, that present-day monsoon, sea surface temperature is one of the key features. Because if you go back to 8 million years, you don't have many proxies. So try to correlate, I hope that you will be doing it in a PhD, with the marine records from the Arabian Sea, Central Indian Ocean, Bay of Bengal, and see that what they speak about the Indian monsoon. Because as I told you, the marine records, they talk about the general monsoon because it is the wind variability.
Yes.
While your horizons, they indicate the climate at the time of deposition at that particular place.
Yes, sir.
So if you can correlate, that will be very good for your work.
Okay, sir.
So can we go to the next speaker if there are no more questions?
Professor Pant is asking some question.
Yes, sir.
Pankaj?
Professor Pant has some questions.
Professor Pant, okay. Yeah.
Abdul,
yes, sir.
I'm curious to know, you have shown a sampling in different segments of Shivalik.
Yes,
so, what is the proportion of paleosol versus the rest of the sequence? I mean, is the paleosol very common, or are you?
No, sir. In the lower Shivalik, muddy stone dominated sandstone we are getting. So in we can say in lower Shivalik, paleosol is more than in middle Shivalik.
All of your data is from the paleosols only, or from other lithologies also?
Sorry, sir.
What you have derived conclusion, what you have derived data is from paleosols only?
Yes, sir. Yes, sir. Yes, sir. We have sandstone data, sandstone sample, but not done it for petrology. We will do in future.
Sir, at this moment, we have this information based on only from the detailed characterization of the paleosols in the field, in the lab, and the clay mineralogy and paleography. And we are unable to do the other analysis because of the problems here. So we are hoping that XRA works. We have geochemical liver. But overall, we have a very high resolution record of these all paleosol features now.
So what my point was that it is the record of the interaction of the formation with the atmosphere, but
yes,
but it's not the sedimentary record of this Shivaliks.
It does. It is basically forming in the overbank sediments of that. So it is basically talking about in terms of that you have some kind of stability or stable surfaces being there, and also you can create a kind of, we do the very detailed sedimentology of these things, we can create a kind of continental sequence stratigraphy or terrestrial sequence stratigraphy.
So we will discuss this later because two conveners should not delay the program.
Okay, I'm not delaying. We can
No, we are on time.
Yes,
Let us encourage some discussions that are there.
Thank you.
I was even wondering whether these paleo salts contain some pollens and spores.
Sir, pollens, I have got the best and the worst experience. I took red paleosols from this Kangra Basin in Oxford for 2 months. I was struggling to find a any kind of pollens because of these highly oxidizing conditions.
Okay.
Paleosols in these kind of condition are not good in candidate for palynology. You may find some other features. For example, you have some roots, you may have some inorganic carbon, those kind of. But palynology, if anybody has done, it is misleading.
Okay. Well, the next presentation is again by group of Pankaj Srivastava. It is by Rohit Kumar on the clay mineralogical evidence of rapid warming associated to Paleocene-Eocene thermal maxima, PETM. So Rohit, are you ready?
Yes, sir.
You have grown long hairs in lockdown.
Yes, sir.
So totally preventing you yourself from hello. So, okay. So the abstract appears on page 49 of the abstract volume. Go ahead, Rohit.
Okay. Is it screen is visible? Hello.
Yes, it is visible.
Okay. Thank you. Good evening. I will be presenting on the topic clay mineralogical evidences of rapid warming associated to Paleocene-Eocene thermal maxima in fine-grained sediments of Akli Formation, Barmer Basin. So that will be the layout of my presentation. As we know that the at approximately 55 million years ago, there was a increase in temperature which reached up to 5 to 8 degrees centigrade in the Earth's surface. That is known as the Paleocene-Eocene thermal maxima or late Paleocene thermal maxima. This extraordinary warming event have been reported across the globe from the marine environment as well as from the terrestrial environments, and it is crucial to understand this warming period because it is widely considered as the ancient analog to the modern climate changes defined by a rapid rise of atmospheric CO2 that are even higher than those at 55 million years. So the PETM lasted approximately for 200 kilo years, and with acidification of the ocean, there is negative carbon isotope excursion and enhanced terrestrial runoff during this short interval. So these periods deeply affect the climate of land areas and thus the mechanism of soil formation, which links the PETM to clay mineral formation. So keeping this in view, we explored one 32-meter fine-grained succession of Giral lignite mine of late Paleocene, early Eocene age from the Akli formation of the Barmer Basin. Barmer Basin, which is located in the west of Aravalli and formed because of the reactivation of the ancient rift zone of Western Indian plate. This map represents the several other lignite succession in the northwest India. So the objective of this study to use the clay mineral as a tool to understand the evidences of rapid warming, which is associated to PETM in fine-grained sediments of Akli formation. For that purpose, we have used this following methodology, and this is the detailed lithostratigraphic log of the Giral mine. So in this, in the field investigation, we have seen the silty clay to clay sample layers of the clay. We have identified some metals which vary from orange to reddish in color. There is some fibrous gypsum also have been identified in both within the sample, some of the samples, and some layers of gypsum also have been identified in this section. Some biogenic activities or bioturbation have also been seen, and then some millimeter scale layering of clay of yellow color have also been seen in these sections. Some of the samples show some cavities which may represent some microbial organism activities. Then we have identified some charcoal in this profile, which vary throughout the lithostratigraphic log. So at this sample, this RJ5 samples, at this time period, the amount of charcoal which have increased up to 20% from the upper and lower part of this section, and then this keep continuing, and again we have a small peak of this charcoal in this stratigraphic at this particular depth. These charcoal have been reported by various authors in the PETM during the time of PETM, and it may reflect some evidences of forest fire during that time. Then we have identified the gypsum in this section, and that gypsum is fibrous and transparent throughout this and it has varying proportion. In this particular depth there is a peak, and then again we have a peak at this particular time. So there are two peaks of gypsum also have been identified. Then we have done some bulk XRD to understand the composition of these samples, where we have mainly phyllosilicates. Apart from it, there is in a small amount there is quartz, feldspar, mica, and some of the sample shows the intense peak of the gypsum, as well as some iron minerals like hematite have been identified in these samples. We have done the detailed clay mineralogy for this purpose, for this study, and that shows there is some strong peak of 17 point angstrom, 7.1 angstrom, and 3.34 angstrom and 3.14 angstrom have been identified. We can see that this 14 to 15 point angstrom peak at Ca, which on glycolation shift to 17 angstrom peak. And we also have identified second order smectite in this Ca glycolation sample. Then when we heat this K saturated sample till 330 degrees centigrade, we are getting 10 to 11 angstrom, 11 to 12 angstrom peak, which suggests that there is this mineral is low charge smectite. Apart from kaolinite, and we can see that in the kaolinite, kaolinite collapse at 550 degrees centigrade, which is characteristic properties of this mineral. Similar results have been identified from the fine clay mineral data. Then at this particular depth, we have seen the similar minerals, but there is a intensity of this kaolinite have increased in this particular depth, and there is a decrease in the amount of smectite have been seen. Then again at this particular depth, we have similar mineral composition, but the intensity there is change in the intensity. So we have correlated these three profiles, and we have seen that there is this kaolinite which have increased up to 20 degrees centigrade in this particular depth, and the various authors have presented that the increase in amount of kaolinite at this particular time could be related to Paleocene-Eocene thermal maxima. And then in conclusion, we can say we have seen that there is in the total clay fraction, there is increased amount of the kaolinite in at this particular depth, then it had decreases, and then again we have a small pulse here. Similarly, in the smectite, there is decrease in the amount of smectite, and when we see the fine clay data represents here the high resolution of that pulse, and we do have this charcoal's presence of this charcoal at this particular time, and the pH of these clay sediments also showed a change from 6.9 to 4.3 with a rise in gypsum incrustation at this level. So this pulse recorded at this level, and the presence of increase of kaolinite, a decrease of smectite, and there is also increase in the kaolinite by smectite ratio. The presence of charcoal and gypsum may refer that there was that may indicate the possible signature for rapid warming, which can be associated with the PET. Thank you.
Okay, thank you, Rohit, for presenting on time. The talk is open for discussion. Dr. Pant?
Rohit, I have a very small question.
Yes, sir.
What gives the characteristic yellow color to the clay which you have identified?
This is basically bentonite, but we have identified various colors of clay-rich horizon in that table. It may be because of some mineral alteration.
Okay, thank you.
Rohit,
Yes, sir.
Akli is famous for its bentonite deposit. So there is actually in Akli formation, there is actually India's one of the biggest smectite or bentonite deposit is there.
Yes,
So smectite is already very well known for several decades and represented or to be present. Do you think that this smectite, this bentonite deposit represents deposition at that point of time or deposition at the time of PETM?
Sir, various papers I have seen, like by this Tripathi et al. 2009, they on the basis of the various regional plates, they have proposed this age from late Paleocene to early Eocene, and there is paper by Rana et al. 2005. They have also suggested this age of the age of this formation at this particular time on the basis of various fossil records.
Okay, so when you log this section, where is the bentonite
Sir,
deposit with respect to the charcoal or the coal deposit?
So is it screen is visible?
Yes.
Yes, yes. Please go ahead.
So the ugly mine section.
Okay, sir. Yes.
ये तो प्री कैंपेन दिखा रहे हैं.
No, sir, मत दिखाइए.
माइन का सेक्शन नहीं है ये.
Yes, sir. Yes, sir. Yes. So, sir, we have this detailed section. So, from this particular depth, below this particular depth, we have lignite deposits. Above this, most of the section are the smectite rich layers of the clays.
So that is what I was saying, that smectite is present in plenty in that unit. And
yes, sir, you are right. That place is being mined for that.
Yes,
it's a beautiful clay. I have got some good sample. If anybody wants to try on it, it is there with me in my lab.
I did my MPhil 40 years ago.
You will get younger.
Yes. Okay, thank you, sir.
So Rohit, it's a wonderful presentation. I have only one question.
Yes, sir.
Once you go to the section,
yes, sir,
and one doesn't know about the Paleocene-Eocene thermal maximum, okay? Is it visible physically in the section?
Sir, not in this section, but some of the papers I have seen, there is presence of red clay is identified in various section, and on the basis of, and then they have identified it as a PETM boundary in various sections.
Okay.
Sir, I add over a minute for here.
Yeah,
yes, sir. It was very interesting. At the almost end of 4 or 5 days, we could reach to this spot in the evening, and we hurriedly sampled in 2 hours for all these kind of things. And when we analyze this thing, we have found that the amount of kaolinite is doubling almost at the Paleocene-Eocene boundary. And that is what is given some signal. And also at the same time, we looked into the sample, there is an sudden increase of the charcoal. That also says there has been some kind of fire activity in the surrounding area that possibly caused this kind of event. And that is giving some signal that this is the PTM we have here in India.
Okay. Thank you, Rohit.
Thank you, sir.
So, next presentation is by Divya Murli. Divya Murli, are you there?
Yes, sir.
Very good. So, Divya will speak on reconstructions of quaternary paleoclimatic variations by using multi-proxy data analysis, a case study from Kollam district, South Kerala. The abstract appears on page 51 of the abstract volume. Divya Murli, you can start sharing screen.
Okay, sir.
After this, we have only 2 presentations left for the day.
There is one more session, Devesh.
Huh?
There is one more session.
Yeah. Oh, I meant, I'm sorry. I meant about this session.
Sir, can I start the presentation?
Yes, Divya Murli, you can start.
Good evening, all of you. Now I am going to briefly talk on reconstruction of quaternary paleoclimatic variations by using multi-proxy data analysis, a case study from Kollam district, South Kerala. The quaternary period is considered as one of the most eventful periods. Study is intends to identify the previous climatic conditions prevailed in South Kerala, Kollam district, India, by using granulometric analysis and by biomarker indicators. This is map of the study area, Kollam district. This district is gifted bodies such as Ashtamudi Kayal, Paravur, then and freshwater lakes such as Chittumala and Polakara. In the present study, 5 boreholes were collected from different parts of the study area by using a rotary drilling method. 2 of them are from floodplains of Ashtamudi Kayal, that is, one is from Mandro Island and another one is from Perinad. The third one is from the floodplains of Paravur Kayal, and one is from Himala Lake, and the last one is from Polakara. Here is the core depth of the 5 core samples. Mandro is of 28 meter, Perinad 15, Chittumala 11.5, Polakara 11 meter, and Paravur is of 17 meter. The samples were subsampled at every 50 centimeter for the further analysis. And the grain size, that is granulometric analysis, were conducted by standard method of sieving and pipetting. Total nitrogen and total organic carbon by CHN analyzer. Next, about result. First one is for grain size. We know that grain size is an important environmental proxy for the paleoclimatic studies. The variation in grain size can be attributed to energy level, velocity of water, internal climatic conditions, especially rainfall. This is the downcore variation of sand, silt, and clay particles of the study area. This is A is for Mandro Island. In the case of Mandro Island, it is predominantly composed of sand-dominated sediments. 2 peaks, one is at 8.5 meter and another one is at 27 meter. At these 2 depths, silt show relatively high MO. Both sand and silt particles shows a drastic variation. In Mandro Island, up to 6.5 meter is classified as sand. Then come silty sand with often occurrence of sand. In the case of Perinad, Perinad borehole is also characterized by sand-dominated sediments. Both sand and silt content fluctuates drastically along the entire colon. Up to 5 meter is classified as sand. Then comes silty sand and sandy silt with often occurrence of sand class. Clay particles shows a irregular variation. The third one is Chittumala. In the case of Chittumala core is also a sand-dominated core. That sandy silt is present. Clay particles show a peak at 4.5 meter depth. The fourth one is Polakara. In Polakara, there is a silt and sand dominated sediments, but clay shows only one peak, that is at 3.5 meter depth. In all other cases, it keeps a consistent behavior. Last one is for Paravur. In Paravur borehole, silty sand with the often presence of sandy silt. This is the
Yeah, please try to conclude.
in the study area. Okay, sir, these are the ternary plot of Petra, which shows the environmental condition of the sediments during the deposition. Here, all the core samples fall in category 4 of the diagram, which indicate the relatively violent environment of deposition. Exceptions are present in 3 cases: one sample from Monroe and one from Polakara and another. This is the downcore variation of total nitrogen, total organic carbon, and their ratio, that is TOC by TN of all the 5 boreholes. In this, both Monroe and Perinard shows high TOC by TN ratio, which may be due to the presence, the organic matter may be the allochthonous source. There may be C3 plants and C4 plants. In some cases, presence of low value is present, that is low ratio of TOC by TN, which may be due to aquatic phytoplankton activity. In other 3 cases, that is for Chittumala, Polakara and Paravur, these 3 boreholes are characterized by low TOC by TN ratio and high values are present in certain depths. My conclusion, the 5 borehole locations.
Yeah, you can leave your conclusion slide open. Don't read it.
Okay, sir.
Okay, we can read it ourselves. So I will utilize this time with your conclusions to the audience. The talk is open for discussion.
Yes. Okay, sir.
So if there are no questions, can we go to the next presentation? The next presentation is by Barnita Banerjee, co-authored by Wasim Raja, Syed Masood Ahmed, Babu and Niharika Shukla. She is going to speak on 70 kiloyear record of monsoon-induced productivity change and terrigenous flux variation in southern Bay of Bengal.
Good evening, sir.
Yeah, Barnita, are you ready?
Yes, I'm ready.
Yeah, I am also very happy with the monsoon session. We have monsoon in Delhi and it's raining outside. So that is the contribution of this session and various speakers. We thank you for bringing the monsoon at least in Delhi because it was scorching heat. So Ashutosh informed me that it's raining outside. So
Really, sir, you could have asked the session before, no, few days. So Delhi would not have gone through heat wave.
Yeah, we could have kept this as the first session.
Yeah, is it? Are you sure it is monsoon?
Partho, let us enjoy monsoon, not find the cause of it. The only thing is वक्त के पहले किस्मत से ज्यादा कभी नहीं मिलता. तो वक्त आ गया है तो वो राजीव निगम के आने से मानसून आया. So Barnita, please start your presentation.
Yes, sir. So is it visible?
Yes.
Okay, so good evening, everyone. I am Barnita and I work in as a scientist in NGRI. So I will be presenting 70 kiloyear record of the monsoon-induced productivity changes. So to start with, what is productivity? So basically, a productivity refers to the production of organic matter by phytoplanktons. Now, these phytoplanktons, what they do is like they convert the inorganic carbon into organic carbon, and this organic carbon is taken by your heterotrophs, and so the aggregate of all these phytoplanktons and the pellets of the zooplanktons and these phytoplanktons serve as food to the zooplankton. So all these aggregate, they sink on the sea floor and give us an idea of the past productivity. Now, when I talk about productivity, so the past productivity is highly dependent on the nutrient availability, and this nutrient availability come from two sources, either the terragenous input or due to upwelling. So this terragenous input and upwelling, indeed both are again dependent on monsoon variability. So my topic also has a term called the terragenous influx. So when I talk about terragenous influx, so terragenous means anything that is land derived, and influx means the inflow. So when I talk about land derived inflow, it can be either by wind or by river. If we are talking about the Indian subcontinent, so in the case of river, it depends mostly on the monsoonal variability, and the wind deposit are basically depends on the aridity. So the study area of this talk is basically in SK. My samples are from SK 14 and 16, which is located atop the 90 East Ridge, and these two are the cores with which we have correlated our data. So the latitude, longitude, and the core length, everything is mentioned here. So about the climate variability of the last 70 years, so we have both. We have included both. That is, the last glacial period is there, and we have the Holocene. So the entire last glacial period, which extends from 110 to 11,700 years, has alternating glacial and interglacial cycles from MIS 4, 3 to 2, and then approximately 11,700 years ago, we have the Holocene, which is the MIS 1. Now it is well established through delta 18 as O and 13C. The monsoonal variation has been well established. That is the monsoon, southwest monsoon. When I'm talking about the southwest monsoon was intensified in MIS 1 and MIS 3, and it was weak at MIS 2 and MIS 4 when the northeast monsoon was quite intensified. So basically, the monsoonal strength varies according to the glacial interglacial cycles. So to see how the productivity variation and terragenous inflow variation took place with the variation of the monsoon, we took few productivity proxies. So number one was your biogenic barium, followed by total organic carbon and the CaCO3 content. So this is the blue one we see here is the SK16 data, and the orange one is the SK14. So what we see that during MIS1, the productivity is quite high. That is, in the Holocene, the productivity is quite high, and during the MIS2 and MIS4, the productivity is low in SK14 as well as SK16 sites. And we have here, this is the delta 18O published graph of SK14, and this is the SST graph from our lab of SK14. So we see that the when the SST is high, the productivity proxies are quite high. So the productivity proxy shows a variation with SST, which in turn is affected by monsoon variability. So this proves that the sites experience a high nutrient supply during strong monsoonal period, which is well established that during MIS1 and MIS3, the southwest monsoon was quite intensified. So the nutrient availability, which I was talking before, must have been due to increased freshwater flux, terragenous supply, or it might be due to upwelling in the region. To know that whether the terragenous supply was actually high in this region during the intensified monsoon and when the productivity was high, we took a few terragenous input proxies, which is the aluminum percentage, the titanium percentage, and the laser particle size analysis. And what we saw that it was quite opposite and of the productivity trend, that during MIS2 and MIS4 in both the cores SK14 and 16, we find that the terragenous input was quite high when the southwest monsoon was weaker, and when the productivity, we are finding the productivity is high when the southwest monsoon is quite intensified, we are finding the terragenous input at our site is quite low. And this was quite surprising because we expected that it was the terragenous input that was giving rise to the southwest monsoon. But it is well established that this site, that is SK14, receives much of the sediments from Irrawaddy River and not from Ganga and Brahmaputra. This was established through strontium isotopes. And this Irrawaddy River has a tendency that when southwest monsoon is intensified, most of its sediment plumes goes towards the eastern side. But when the northeast monsoon is intensified, the sediment plume is diverted towards this side, that is the western side. And that is why when the northeast monsoon was higher at MIS2 and MIS4, we are getting higher terragenous influx when the northeast monsoon was quite intensified. Then we did chemical weathering proxies, and we find that indeed at the Holocene, when the temperature was quite warm and humid conditions prevailed, we have low K by L ratio. So there was dominance of K by Al weathering, chemical weathering during the Holocene, while in the last glacial period, this was mainly dominated by your physical weathering is here. And then we have compared it and correlated it with strontium, established strontium isotopes of SK14 and another core nearby. And we see in the strontium isotope proxies also tells the same, that the chemical weathering dominated in the Holocene. So to see that what was the spatial variation and the scenario in the entire Indian Ocean, we correlated our data with that of the Arabian Sea and the Northern Bay of Bengal. And what we find that the CaCO3 proxies in the Northern Bay of Bengal core 19B, we see that the productivity proxy CaCO3 was quite high at MIS2 and MIS4, unlike our core. And this was because this core is basically situated just at Mahanadi Basin, and it receives a lot of heterogeneous input. And this CaCO3 signature is diluted because of the lot of heterogeneous input that is coming from the land. But the TOC proxies tells the same story as our core, that is the productivity was high at MIS1 and MIS3, and it was low at MIS2 and MIS4. But in the Arabian Sea, also the trend is different from Southern Bay of Bengal. Because the Arabian Sea tells us that at MIS2 and MIS4 the productivity is quite high, and that is because Arabian Sea has a lot of convective mixing caused by the winter monsoon, and this convective mixing results in upwelling, and that gives rise to high productivity at MIS2 and MIS4. And if we compare the heterogeneous input with the Northern Bay of Bengal, so what we find that the heterogeneous input, this is our study and this is the NGHP. So we see that the heterogeneous input in the Northern Bay of Bengal is high at MIS1 and MIS3 because it is located at a proximal distance from all the river, that is Mahanadi, Ganga and Brahmaputra. So obviously the heterogeneous input will be high when the monsoon is high. And in the Arabian Sea, again, the heterogeneous input is quite high at MIS2 and MIS4. And this is mostly because the Arabian Sea receives a lot of aeolian input. So when at MIS2 and MIS3, the northeast monsoon was quite intensified and there was a lot of aridity in the region. So a lot of heterogeneous input had come because of the aridity in the region, and that is why it has high heterogeneous input at the colder spells. So the conclusion is that productivity at the study area is higher during the warmer period associated with intensified ISM, and the heterogeneous supply is more during the colder spells as the study area receives enormous sediment load from the Irrawaddy river, which gets displaced.
Bharnita, just leave this conclusion slide
okay.
open to the audience.
Okay.
Yeah. Leave the conclusion slide, show conclusion slide.
Yeah, 1 minute.
Yeah. Yeah.
Yeah.
Yeah. The talk is open for discussion. Well, if there are no questions, Bharnita.
Yes, sir.
You are saying Bharnita Banerjee.
Yes, sir. Yes, sir. Yes,
girl
sir.
we used to teach in Delhi University.
Yes, sir. Your student, sir.
Yeah, matured to the scientist level. Very good.
Thank you.
So I have one question to you.
Yes, sir.
Well, that may not be much related with your research, but you said in the beginning that the last glacial started at 110 kiloyears and up to the end of Younger Dryas, okay?
Yes, sir.
And it does include MIS3 also?
Yes, yes, yes.
MIS3 is from 60 to 30 kiloyears. Am I right?
Yes.
Now, your all interpretations, you treat MIS2 and MIS4 as colder periods, while MIS3 and MIS1, that is Holocene, as warmer period.
Yes, sir.
But yet MIS3 is included in last glacial.
Yes.
Can you tell me the reason?
So actually, in the glacier also we have things like stadial and interstadials. So, so that is the reason. Like we have.
That is not the reason. Look, just one word of caution. The marine isotope stage are based strictly on glacial and interglacial stages, based on the depletion or enrichment of the heavier isotope of oxygens in marine benthos. But that may not be exactly parallel with the cooling or warming. Remember it. Because in MIS 3, the sea levels were about 60 to 80 meters below what they are today. And that is why MIS 3 is not truly considered as an interglacial period. And that is why it is included in the last glacial period from 110 to 11.7 kiloyears. Though it is an odd number stage.
Yes, sir.
So based on that, please try to see a wonderful point which has come out recently in many studies, that not every glacial and interglacial stages, by marine isotope stage I mean, they are same in nature. Every glacial and interglacial age stage is different than others. And this with regards to the amplitude of warming or cooling, the profile of the interglacial or glacial. That means warm, cool, warm, cool, warm, cool. So these profiles fine-tuned with Indian summer monsoon. Now this is the challenging area. So try to fine-tune your studies with, because these stages are quite long. See, MIS 30 kiloyears.
Yes, sir.
And you have record of monsoon at millennial scale.
Mhm.
So if you can find out the profile of a marine isotopic stage, any MIS stage is not warm throughout, or neither the even number is cool throughout.
Yes.
It has the variation. And with that variation, monsoon is correlated. Also, my last comment is, MIS 3 has been a center of attraction for many, because MIS 3 includes Antarctic isotopic maxima, AIM events, where you have Antarctic isotopic maxima. That means the warm events. As you know, the higher isotopes, they get enriched in ice cores.
Yes, sir.
These warm events have been tied to the monsoon. There are 10 AIM events. So it's a wonderful study. So try to make it more global.
Yes, sir.
And try to find the causative factors for the monsoon.
Okay. Sure, sir. Thank you so much for your suggestion.
Can I have just a small query?
Yes, sir.
Vanita, thank you for doing a very good presentation here. I was just wondering, in one of the slides you showed that for weathering intensity you use K by AL. Why did you go for K by AL? Because normally it is for mobile versus immobile elements are taken, where the calcium, magnesium elements are on top, and then you divide them by alumina and kind of thing. Why K by L?
So basically, K is mostly present in the
Because
light.
you see, the K potassium has got a lot of problem when you do these kind of studies. It gets redistributed because there is a kind of diagenetic alteration, and during even if it is post deposition, there is also redistribution is there. So calcium, magnesium could have been more useful. Okay, now your answer.
So actually, we have supported it with strontium as well, and then we are also. This is a very preliminary study that I have presented. We are also going for the XRD, and we'll support it with few more analysis, and then we will present. So this I presented today is a very preliminary study that we are doing, and then we'll take out few more things.
Okay. So please look for this one.
Sure, sir.
So geochemistry is very interesting.
Yes, sir.
In looking in the weathering indices, but this particular ratio may not give you the all information.
So we have strontium also, and strontium neodymium also, and we'll go for XRD also. So I think then.
Thank you.
Good, Barnita. Thank you.
Thank you so much, sir.
So this was last but one presentation by one of our old students, and now the last is by our new faculty, Dr. Naresh Rana. Naresh, are you ready?
Yes, sir, I'm ready. Yes.
Yeah, Naresh will speak on role of topography and sediments in amplifying the peak flood discharge of Rishi Ganga flash floods, implication for flash flood hazard assessment. The abstract appears on page number 53 of the abstract volume. So Naresh, please go ahead.
So, am I visible, sir?
Yes.
Okay. My name is Naresh Rana, and I'm going to present this study on behalf of my group. And I'm going to talk about the role of, I'm going to talk about the Rishi Ganga flood and the role of topography and sediment supply condition in amplifying this disaster. So, because it's hard to imagine the size of the flood just by numbers, so I put these images to compare the pre and post flood conditions of this area. And this was the site where more than 100 people were buried and or washed away. This is also important slide which gives idea about the magnitude of this flood. And you can see that in this circle, you can see that there is a building which is a 4-story building. And this bridge is also more than 20 kilometers high from the river bed. So it gives you some idea about the size of this flash flood. Usually in Himalaya, we have this kind of flash flood either due to the glacial lake outburst or the landslide lake outburst, or sometime by the cloud burst. But none of these causes were responsible for this flood. So this flood, this event raised two important questions. One was regarding the genesis of this flood, and another was what dictates the pattern of the hazards, or you can say pattern of the amplitude of flood in the downstream valley. So let me give you some idea about this area. So this is Alaknanda River, and this is Dhauliganga River. Again, this is joining Alaknanda at Vishnuprayag, and this area where you see the high concentration of glacier is the Rishi Ganga Valley, which comes in the Nanda Devi Biosphere Reserve. So this is the Rothi Valley from where the flood actually started, and this is the glacier. So you can see in this image that there is a very high gradient in this portion. In this 10-kilometer stretch, there is a difference of 1,500 meters in height. And let's come to the mechanism part. We were in the valley on 3rd and 4th of February, and on 3rd and 4th February, there was a snowfall. But after that snowfall, there was a sudden increase in the temperature of the area, and this makes a favorable condition for a high melting of snow and maybe for the avalanche. But in addition to that, there are some more regions for this that have been suggested for this flash flood, and that was the geotechnical regions also. This was the pre-flood, pre-event image, and this is the post-event image. And you can see that some mass from this area has been slipped down. And we tried to calculate the volume of this mass using considering that it is a simple triangular wedge, and the mass, the volume of this mass would be around 10 million cubic meter. And this mass was accumulated at this region shown in this rectangle.
Rahul, inform him he is disconnected.
Okay.
Naresh? Yeah, please continue.
Can you hear me, sir?
Yes, please continue.
Hello?
Yes, please continue.
Yes, sir, we can hear you. Actually, I lost one connection, so I'm sitting on another computer. Sorry for that. So it is because of the
Take your time. Take your time.
internet fluctuation.
Take it easy, no problem.
Just give me a few seconds, sir.
Yeah.
Can you see my screen, sir?
Yes.
Okay. So I was here.
Yeah, you detect 10 million cubic meters of mass. Yeah, that is all.
Okay, sir. Okay. Thank you, sir. So this mass was probably accumulated here in this place, and maybe there is a possibility that there was a. One second. I'm sorry. So
yeah, we can hear you. Please continue.
Yes, sir. Actually, just 1 second. I'm trying to make sure that it will not create any problem. Okay, sir. So this mass was accumulated here for some time. Maybe it has created some damming here, or it was immediately melted into water. So let's see the pattern of the damage in the upstream reaches. So you can see in this image that in this portion there was all the material which was accumulated here for years has been scrapped out in seconds, right? And if we go downstream of the Rani village, there is a huge accumulation of sediments, and we tried to compare the pre and post flood photographs, and we find that there was an accumulation of an average 4-meter sediments in this stretch. If you see the extent of this flood from upstream to downstream, so we see that there was a clear declining trend, and this was near the source region, and this is Gochar, which is around 120 kilometer downstream of this portion. And in Gochar, you can see that there is no appreciable change. There was no appreciable change in the river level. So in order to quantify these changes in the discharge, we tried to measure the cross sections of the high flood levels and gradient of this river using this total station. And we also tried to make a long profile of this section, which suffered the devastation. We also tried to measure the current discharge of this river because there was no data available for whatever reason. And we also tried to measure the sediments that was deposited in downstream of the Rani village. And the volume of this sediment was around 12 million cubic meter. And also note the current discharge, which was 3 meter cube per second. So this is the total station profile that we constructed, and we use this profile to and compare this profile with the video clips, and we calculated on the basis of these two observations that the flow velocity for this region was around 30 plus minus 3 meter cube, and I just put that number, the other number here, that was 32 to 36. This was the back calculated. So they are comparable. So these are some results of the cross sections. And in these cross sections, you can see that there is a declining trend in the cross section, and which is also reflected in the discharge. This left image is the plot of the velocity, flood velocity and discharge. So you can see that there is exponential decline in the velocity and discharge of the flood while going downstream. So the maximum flood discharge for this section from top reaches was 140,000 cubic meter per second, and the minimum was 121 cubic meter per second. So this is a quite big difference. So this is a concluding diagram, and we have tried to put the river profile here, and you can see in this river profile that these crosses, these blue crosses, are actually the gradient, and these gradients are high in the upper reaches where maximum erosion took place, and the gradient is low in the lower reaches where maximum deposition took place. So overall, we want to say by this study that the sediment which is accumulated in this upper reaches because of the paraglacial and colluvial activities also play important role in magnifying the size of flash flood, and this should be taken into consideration while doing any hazard assessment of the area. So these are some conclusions. I'm not really sure whether you are listening to me or not, because it's
you can leave the conclusion for the audience.
Okay, sir.
So that they can read it and interact with you.
Okay, sir.
So we have Professor Pankaj Srivastava and Professor Partha Chakrabarti. They will interact with you. So okay, Pankaj, please.
Rana sir, thank you for doing this presentation on a very recent havoc that has happened. I was just wondering, first it is a little query. How did you get the event photographs? And then, of course, it is very simple and it is good to get the post-event photographs. But how the same photograph was there possible? Was that particular area or location was being monitored already?
No, sir. Actually, are you complete, sir?
Yeah,
okay.
You are audible.
Okay, so actually we were in the field on the first week of this February, and we were taking some photographs for different reasons. And the other reason is when I tried to see the media, and I talked with people that whether they have any photographs of this area. Then I reached there again after this flood, and I tried to click the same photograph to compare that.
Okay, that's and then you're saying that in the upper reaches, the close to the source, you have got more and more of fine-grained sediments, and as you go down, you have got coarser sediments. How this was possible?
No, sir. Actually, I didn't say that. Maybe
you have correlated. In the last diagram, you have correlated. You have suspended sediments, and then you just see at 80 kilometer, you have more double of the suspended sediments. It is the volume.
Actually, sir, this is not from the. If you will read it from, this is the distance from Karnaprayag. This is not the distance from the source actually. So it is reverse actually.
Okay. Okay, thank you.
Yeah.
Partha?
Dr. Rana, first I must congratulate you for showing us beautiful photographs. And this is actually, but my question is something different, because you have shown a triangular wedge in the upstream, and you calculated the volume of sediment that from the triangular wedge. Now, I also saw you in the media, in the TV channel that you were describing from that side. But my question is different, because the product of the event that people have recorded, that is essentially a muddy with some angular rock fragments within it. That is the product that I know the Wadia geologists, they went there and they found that there is an event bed, and this event bed essentially constituted of muddy sediment with some angular fragments within it. Now, my question is this failure of this triangle, or it is the failure of the entire permafrost? Because that much of fine-grained sediment, unless there is a contribution from the permafrost, it is very difficult to get. And then how much relevance of this modeling of the volume that you have done, that has a relevance of on the total sediment budget?
Sir, I just calculated this in order to compare the volume of the sediment that was deposited downstream, to make sure that there is a role of some other agents also, like there is a role of the sediment which is already lying there in the valley because of the paraglacial process, because of the colluvium, because this area is very active, active in terms of landslide and slope failures. So there is already a lot of sediments which is available in that area, and because of that sediments, we have the fine grain size sediments in that material. So it's not just, I think it was not just the composition of this rock, the contribution of this rock mass. It was the contribution of the sediment that was already available in this valley.
Okay. Okay. And my next query, it is not a question, that large number of people got buried and died because of the dam. There are two parts of my question. This number one, will there be a early signaling system that when there is a failure, how far is the failure site from the dam where the people have been buried?
So it was around 25 kilometers, and people had.
So yes, that there lies the question, that if there would have been an early signal system, then couldn't they could have been evacuated from that place?
Definitely, sir. Definitely, they had around 10 minutes to
10 minutes in their hand.
Yeah.
So it was possible to evacuate those people.
Definitely, sir. They had no formal warning system. There was no formal warning system.
Yes,
and
exactly. So why not you basically propose to government that there should be this kind of system? This is more of a discussion, Dr. Rana. It is not a questioning out here. We are
definitely, sir. Definitely, I agree with that. And many people have raised this question, but I wanted to talk one more thing by this study, that this is not just because there are many valleys, there are many dams everywhere in Himalaya.
Exactly.
Right? So I don't think that everywhere this early warning system will work that so well that people will be evacuated in time. But there should be some policy, because these it's not just water, it's the sediment also that can create huge that can convert the water into huge debris flow. So
yeah,
there
exactly.
should be minimum distance.
And Dr. Rana, that lead to another question, that how far upstream we can go for a dam construction.
Exactly, sir. That's what I was trying to show by this presentation, that this shows there is a gradual decline in the discharge. So after Vishnu Prayag, there was very insignificant increase in the discharge.
Yeah.
So for every valley, for every project, they have to calculate the safer distance.
Yeah, absolutely.
Okay, Dr. Rana, we have one question from Rahul. Rahul, can you ask your question?
Yes, sir. Sir, actually, I have been to this area, and as this particular region is very close to the main central thrust, and a few months after this event, there was another similar event in the Sumna village near Malari, which is around 70 kilometers north of this place, and that particular area lies very close to the South Tibet detachment. So, can we relate these two events to any tectonic movements which are related to these two regional thrust systems which are present there?
I think this is too small data to interpret the movement in the South Tibet detachment system. And
that's true, Rahul. The thrust system are very long. See, very spatial extent is very large. And this is happening at a local that may be related, but it cannot be emphatically said that it is related to the thrust.
Okay.
So, thank you, Naresh.
Thank you, sir. Thank you very much.
And so let me summarize. And first thing I want to tell you that we are well on time. So the concluding remarks ends at 6:45. So still we are at 6:37. So we are on time. So it has been a very thoughtful session, I will say, that lot of thought process went on. Starting with the lecture by Dr. Nigam from NIO on the application of foraminifera in understanding the extent of marine pollution and also suggestions for its mitigation. And the talk attracted some of the questions from our faculty members, and I'm sure that Dr. Nigam has been successful in letting us know the power of foraminifera. That's not only for academics, but for industries and societal benefit also. Rest of the session we had on paleoclimate and paleomonsoon. And we had largely been discussing about the paleopedology and the paleosol horizons from Shivalik supergroup, and also from the Rajasthan. The time span ranged from early Oligocene to Pliocene, Pleistocene, and most of these studies were based on finding the qualitative climate signal from the paleosols and relating it to the global events. And you can see that the early Oligocene paper was very important because, as Pankaj told us, that it is published in Sedimentology. By the time I also had a look at that paper, and the early Oligocene has been a very important interval where our boundary conditions change. So I think that more such studies will be coming out from the department. And then we had the couple of studies about the intensification of the monsoon from the Shivalik sediments. And I hope that they will be correlated with more marine records, and a lot of interesting information will be coming. In the second aspect, we had mostly the work from the Holocene monsoonal changes. And people tried to correlate with the bond events and pre-Holocene events. They correlated with the LGM, with the Younger Dryas. There was also a talk by Miss Banerjee from CES, and she gave a review of the Holocene monsoonal changes and tried to correlate it with the global events. That is also published in Holocene, as she said. There was one study, very important, about the textural characteristic of the speleothemes. So far, we have been listening to the speleothemes oxygen isotope as a proxy for the dry and wet periods. But this study correlated oxygen isotope profile with the textural characteristic. And I see a lot of potential here that if it is established with time, this will be a very good contribution, that we can see that the texture also is an indicator of the climate. So that was another aspect which was discussed here. Lastly, Dr. Naresh Rana, as you saw that he had a beautiful photograph of a disaster, and Professor Pankaj asked him that reason why, how he got a pre-disaster photograph. So my only suggestion is, Naresh, wherever you click a photograph, you warn the government that there may be some kind of a disaster, and in Himalaya you can expect disaster anywhere. So I hope that we have been able to do justice with this session. Every speaker finished their talk on time, and due to that, a lot of discussions could be held. And of course, what I feel is that the session has also brought monsoon in Delhi. So I will request the rapporteur of this session, Dr. Bircha Prasad, to please make a summary of the report and show it to me, and we will together send it to the conveners. So
Exactly.
thank you all. Thank you very much.
Thank you, sir. Thank you.
Over to you, Pankaj and Professor.
We can begin the last session. I can see as Dr. Singh there. Dr. Singh is not there. Then Manika is there. So
Yes, sir.
please see to it that the time is maintained.
Sure, sir. Sir, I can start the session?
Yes.
Yes.
Okay, sir. So I welcome you all in the final session of the seminar, that is Techniques in Geosciences. And I hope this session is similarly interesting as all the other sessions we had for the last 2 days. So without wasting any time, I would like to invite Juby Thomas for the first presentation, that is soil moisture downscaling, using vegetation index and land surface temperature over a semi-arid region. Juby, can you please present your work?
Yes, ma'am. Good morning, ma'am, and good evening, everybody. Am I audible enough?
Yes, Juby.
Is my presentation like visible to everybody?
Yes, it is visible.
Yeah. Thank you. Good evening, everybody. My name is Juby Thomas, and I'm a PhD research scholar in the Department of Geology and University of Delhi. And today's my topic is soil moisture downscaling using vegetation index and land surface temperature over a semi-arid region. This is the framework of my today's presentation, and this soil moisture is defined as the total amount of water within the unsaturated zone. And in this study, I'll be talking only about the surface soil moisture layer, and I'm not talking about the root zone soil moisture, root zone soil moisture. And the importance of soil moisture is understanding the energy and water balance regionally and locally, and it controls the interchange of energy and water fluxes at the interface of atmosphere and land surface, and it also determines the partitioning of precipitation into surface runoff and infiltration. And soil moisture has direct impact on agriculture, irrigation, biodiversity, terrain management, and trafficability, and it plays a pivotal role in numerical weather prediction models. And it is one of the causative factors of drought, floods, and geohazards like landslide and debris flows. Although this is of utmost important, it is very difficult, and it is very difficult to retrieve the soil moisture data globally. One of the conventional methods were using soil moisture observation network, and they were very expensive, and they were facing many problems like inaccessibility of the terrain and all, and retrieving soil moisture globally through this conventional soil moisture observation networks were nearly impossible. Here comes the role of satellite remote sensing. And satellite remote sensing, with the help of passive and active microwave sensors were able to retrieve the data globally. And these are the major satellite missions which were used to retrieve the soil moisture globally. And I have used this data to downscale it. Advanced microwave scanning radiometer 2 data, which was of 25 kilometer resolution, to downscale, and I have downscaled to 1 kilometer resolution. And one thing I wanted to tell you here is about this MAP mission, which was soil moisture active practice, which active and passive, which was having an active sensor which was supposed to give the data in 9 kilometers square resolution. Unfortunately, after 3 months of the launch, this sensor failed, and still it is giving the data in 36 kilometers square. And here comes the role of this study, soil moisture downscaling. The finest data available right now is of 25 kilometer resolution, and even this finest data is not enough for modeling and local level studies. And this is a pictorial representation of 4 EMSA2 pictures. As you can see, this is the 25 kilometer resolution data, which means for this 625 kilometer square data, we will be having only one value. Same here also. What I have done, the study has done, is like we have downscaled or disaggregated the data to this, where we can see every pixel represents 1 kilometer square, and we have every 1 kilometer square 1 kilometer square area, we have got one unique value. And study area, I'll talk about the study area right now. The study area here is in Uttar Pradesh, UP, and it has flat topography, and this is it has a humid subtropic climate, and the annual rainfall is less than 100 centimeter. And this area is of mainly agricultural land. And one of the reasons we have chosen this area is because of a well-established soil moisture observation network. And here, this is the study area. Here we can see these are the 4 EMSR2 pixels. And here in the study area, we can see here this whole pixel, where this whole area was represented by only 1 pixel. And this pixel was like for the almost all area of Varanasi will be having one value for one daily. We'll be having only 1 value. So what the study has been done is, like, we have disaggregated into this many pixels. Here we can see the importance of this. And I have used this data. So this from here I have used the LST day and night, and which is of 1 kilometer resolution. It is the daily data. And another one is NDVI. Again, it is NDVI and vegetation index quality indicators, and composite day of the year. And again, it is 1 kilometer resolution, and it is 16 days interval data. And we have later interpolated to daily. And another one is C-band derived soil moisture from EMSR2. This is day and night, which is of 25 kilometer resolution. We have used the Hydra probe and of part of the soil moisture network for validating our data, validating our downscaled product. And we have used DUM to see the topography, to check for the topography correction, and SOA maps for administrative boundary. Under this, there were a lot of the huge data sets, and a lot of computation has been done in our statistical programming language, and the output of the study has been visualized in QGIS. Both are free, and they were open source. And this is the methodology of the study I have done. And these 3 products are the major input data. And this MODIS NDVI data I have interpolated to daily in R using the MODIS extra and MODIS package. From here we have got the fractional vegetation cover. From the MODIS LST we have taken the skin temperature, and from EMSR2, and then we have, with the help of soil evaporation efficiency, we have made the disaggregation algorithm, and we have derived the high resolution soil moisture. For these are the formulas we have used for this thing. I'm not explaining this formula because of the time restriction. And this one I would like to explain. This one, one of the most important part of this soil moisture disaggregation algorithm was this part, which we have solved by using this equation. This equation, in which A is an experimental tuning parameter, which we have decided based on multiple runs, and we have compared with we have used annual runs, and again we have used monthly runs, and this N is the number of days. And this is the results we have, what I have obtained. And here we can see we have got almost 73% of correlation with the data. And I have validated the results in 2 ways. One is of temporal data, which I have validated in BHU and the Hydra probe at the Banaras Hindi University, which was I have daily validated the around 6 months data I have validated, and this was showing 73% correlation. And another one was for these days I have validated spatially. I have validated this thing at again at this location, again at the 44 locations in the Varanasi district. And for spatial validation, this is the correlation I have got. And this here we can see most of the areas were having this downscaling algorithm. The soil moisture derived from the downscaling algorithm were having good correlation, and there were few places it was not able to pick up properly. And here we can see the box plot. In the box plot, we can clearly see this is the box plot of the NRMC of the downscaled soil moisture, and which you can see the median is well below this thing. And this is the NRMC of the satellite derived soil moisture, which you can see that the downscaled soil moisture is performing much better than the satellite-derived one. Coming to the conclusion, the downscaled soil moisture shows good correlation spatially and temporally. Downscaled soil moisture shows better correlation with the ground data than the MSER2 data, which is satellite-derived one. And one thing which we will be improving on this one, this downscaling, this peaks in the ground data, this algorithm was not able to pick up. These peaks must be because of the irrigation data, and we are trying to improve the algorithm to get these peaks also. And one of the things, although the satellite data we may see like these are readily analysis ready, they are not really ready, and we were facing many problems like a lot of NA values and lot of no data pixels in the value, and we were using a gap filling technique. Although the gap filling technique were commonly used, but if you have a proper and perfect data, the algorithm will perform much better. And the days where we had the data with like no data pixels were performing not really good. And these are my references. And thank you.
Thank you, Joby, for your presentation. It's open for discussion, so anyone who would like to ask the question, okay, Apur. Yes, Apur, you can ask.
Thank you, ma'am. Joby, you did a good work. I just wanted to ask, what is the implication that you are trying to use from this data? Is your study or modeling technique can be universally applied?
No, we cannot. No. We cannot globally like apply the model, because one thing what I have discussed here is like this flat topography. One of the major things which determines is like the altitude. The topographic correction we have to be done, which we are again trying to use that one. And another one, we have used this thing for a small region right now, like not really small, like this on high altitude terrains, this algorithm perform not really good. We need to improve on that.
Pankaj sir.
Yeah. Really, thanks for a good presentation on using the remote sensing, measuring the soil moisture. I was just wondering whether have you tried to see the available reports and the data that is already coming out from the very important institute like ICR. They have got MBSS, and so they have got huge amount of ground truth data. They have got, I think, published maps also. This was one part of the question. Another part, there is a definitely satellite data is going to give you some information, but the kind of resolution that you're looking possibly will not be there. So is it possible, have you looked into what is happening today? Nowadays, the drones are being applied. Are you aware of that one? There are there's a big projects coming out from the DST. They are supporting a lot of studies based on this kind of thing. Not only soil moisture, but there's other studies also. So you can also, do you have any comment on that?
Sir, I haven't like, for me, like getting drone data is like, so we are trying, and drone data, like drone data is definitely, it gives much better resolution data than the satellite data. And one of the reasons for not using drone data is like it is really expensive and unavailability also, sir.
So that is okay, but what about the ground truth and the already available information from based on the this soil moisture studies done already from the India?
Sir, we have
very high resolution studies are there.
Sir, can I say?
Yeah.
Sir, the soil moisture studies are available, but the regularly availability of data for the agricultural purposes on a scale is not usually available to the people on local grounds. So we would try to give this data in the real time and make available to this data, so they don't need to use or formulate any of the data which are available in the studies.
Real time means, what do you mean by that? Because
real time means, sir, this data, which is the satellite data which is being used here, is available in real time. So the
But satellite
process.
data is also not that. You're not going to get it the same day report and same day
Uh,
satellite image from that one. So that's
uh,
also
so
has
these
got some lag.
data, so they have got the lag, like sir, mainly of week, or sometimes some of the data they are trying to get it on a regular basis of 3 days also.
That's okay. But I was just saying, suggesting that you
Yeah,
when
sure, sir.
you try to find out some ground truth data, there are already very good publications are there. There are publications from the ICR institutes are there. There are some of the institutes are devoted to that one.
Definitely, sir. We have another site also where the ground observation data is being collected. So that would be also used further.
Okay, thank you.
Okay, thank
Thank
you,
you, sir.
Juby, for the presentation. Can I call upon the next presenter, Gomi, for review and revisiting the tectonic map of India using remote sensing and GIS? Gomi,
Yes,
are you
ma'am, I'm
there?
present. Yes, ma'am.
Okay, please share your
I'll be
screen.
sharing my screen.
Yeah.
Is it visible now?
Yes.
Okay.
You have to do the slideshow.
Okay.
Yes.
Yes, ma'am. Okay. Good evening, everyone. The topic of my presentation will be on the review and revisiting the tectonic map of India using remote sensing and GIS technique. Hi, this is Gonmei from Department of Geology, University of Delhi. So, in the first case, I'll be showing you the study area map, which is on the right side. This is a map prepared using GIS application, which is a free application known as GeoMap app version 3.1.6.12. So in this map, I'm trying to show the Indian subcontinent, which is divided into the different major domains, which is the Himalayas, the Indo-Gangetic Plains, and the peninsular India. Inside these domains, we can divide again for simplicity into Western Himalayas, for example, in the Himalayan region, into Western, Central, and Eastern Himalayas. And again, in the Indo-Gangetic Plain, some of the protrusion from the Archean rocks in the form of pockets like Delhi Haridwar Ridge, Faizabad Ridge, Munger Sarsa Ridge, and the other ridge in the Eastern Himalayan region. So the current topic deals with the review and identification of mega thrust and force, which is of around 500 kilometers or greater, and their extension of crustal scale tectonic significance in the Indian context will be discussed. So to study these large features, we require a large amount of satellite datasets. So here the study will be done based on the hydroset datasets plus global ALOS landform datasets using the application of Google Earth Engine, in short, I term it as GEEE workspace. And some other data sets include large earthquake data of magnitude 6 and greater. So when we talk about the tectonic map of India, some few workers have done. As you know, the countless number of maps exist of today are of individual tectonic domains, but there's a lack of seamless high-quality data at large. So some of the workers are done by ONGC and GSI based on the study of surface features evident on satellite imageries. And other maps are done by Balakrishnan and et al. 2009 on the existing map of ONGC and GSI, which are superimposed with geophysical data considering gravity anomalies. And the others include a seismic map of India. It's prepared based on historical earthquake catalogs, seismotectonics, geology, and focal mechanism by Khatri et al. And Parvez et al. And so on. So the recentmost one is the active tectonic based on the tectonogeomorphic studies in India by Mukul and Singh, 2016. This is the methodology flowchart which I followed in my research. Simply, this flowchart is prepared using Microsoft Visio. I think most of you know. Here you will find a free templates or libraries where you can edit, manipulate, can do anything. So in this flowchart, I'm showing you the data collection which I've carried out in my research. For ancillary data, the primary source, I took it from literatures, the earlier published works like GPS velocities, focal mechanism, tectonic and structures, which includes faults, thrust, etc. And for geospatial data, I use a Google Earth Engine Explorer workspace. Here I get a data of satellite data sets of global allows landforms, hydrosets. And on the third hand, I use earthquake data from USGS. ASC stands for Amateurs Seismic Center, based in Pune. And others include GSI, BUCOS, and other published data. From all these data, I superimpose all these data in one platform, that is ArcGIS. It is a GIS operation tool. And from after analyzing and visualizing all this, I update the tectonic map of India, which will be shown later in the following slides. These are all the tools and platforms, websites, which I have used in my research. That is, first one was GeoMap app. I have told you earlier in the first figure. This comes in a very small, small software. Unlike the ArcGIS, it is downloadable and free on the website GeoMap app, which is less than 100 MB. And another one, ASC, Amateur Seismic Center. This is a US Geological Survey. I downloaded earthquake data, which provide data from 1900. And the small dots which are plotted here are of magnitude 6 and greater. And for satellite data sets, I use Google Earth Engine. And in this workspace, you just have to type the name of the data sets, and you'll automatically get it on this workspace. This is how I've done. For those, and again, the Google Earth Engine serves two platforms. That is Google Earth Engine Code Editor. For those who are familiar with the code editing, programming, Python, JavaScript, you can download free data sets for large global scale image. You can just type it here, and then you can search for the API. They will give the predefined libraries for all kinds of JavaScript coding. You just have to draw a polygon, download it, and export it to ArcGIS operation. You can work it out on that. And after all this, I transpose it to Illustrator. I work on Illustrator 2020 for giving a finishing touch. So it's a figure 3 showing the satellite imageries. In here, the satellite imageries is I work it on Google Earth application, and the legends is auto-generated here. And you all know it's a free application.